ask everyone to please be seated and make yourself comfortable.
Please make sure that all of you have registered at the registration desk and have gotten an ID card.
And please kindly switch off or put your mobile phones on silent mode. Thank you. Your cooperation is appreciated. And we would like to inform about the Wi-Fi connection. The user ID is the garden and the username is garden. The password is violet in the small object.
Assalamualaikum warahmatullahi wabarakatuh. Good morning and welcome. The Honorable Director General of Social Forestry and Environment Partnership, Ministry of Environment and Forestry of Republic of Indonesia,
Head of the Sub-Directorate of Species and Genetic Utilization, Ministry of Environment and Forestry of Republic Indonesia, Vice Dean for Research, Community Service and Cooperation, Faculty of Forestry, Universitas Gadjah Mada,
all eminent resources person, ladies and gentlemen who are here in person in East Park Hotel Yogyakarta, and also who are joining online in YouTube channel from wherever you are. I am Elia and
Dian Roma will be the master of ceremony until tomorrow, until the ending of this TIC International Seminar. On behalf of the organizing committee, we are greeting everyone. Hopefully you all are well rested because we will have a big session. We will talk about improving the Clonal Teak Plantation for sustainable management of monsoon forests.
This event was organized by Faculty of Forestry, Universitas Gadjah Mada, and the seminar is part of the 60th anniversary of Faculty of Forestry, Universitas Gadjah Mada, that supported by Universitas Gadjah Mada, Japan International Research Center for Agricultural Sciences or JIRCAS, Science and Technology Research Partnership for Sustainable Development or SATREPS, Ministry of Environment and Forestry of Republic of Indonesia,
Perum Perhutani, Pupuk Indonesia, and PT Bukit Asam Tbk. Thank you for the support.
Ladies and gentlemen, we certainly need to know what the event will look like from today's seminar until the 4th of October. We cordially invite to the podium the Chair of Organizing Committee International TIC Seminar, Dr. Insinyur Sabto Indrioko Eshut MP IPU to deliver the overview program. Please hear a round of applause.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Honorable Dr. Bambang Supriyanto, the Director General of Social Forestry and Environment Partnership, the Ministry of Environment and Forestry of the Republic of Indonesia. Honorable the Director General of Natural Resources and Ecosystem Conservation, represented by Ms. Ratih Listiorini MSc, Head of the Sub-Directorate of Species and Genetics Utilization, the Ministry of Environment and Forestry of the Republic of Indonesia. Honorable Dr. Widianto, the Vice Dean for Research, Community Service and Cooperation, the Faculty of Forestry, Universitas Gadjah Mada, Yogyakarta, Indonesia. Honorable Professor Naoki Tani, the project leader of SATREPS, entitled Strengthening Tropical Forest Resilience Based on Management and Utilization of Genetic Resources Capable of Climate Change Adaptation. Honorable all sub-project leaders and members of SATREPS, distinguished all speakers and participants, ladies and gentlemen. First of all, let me start this international seminar with expressions of gratitude. It is an honor and a privilege for me to have you all here today. Let us acknowledge and appreciate the blessing and mercies of God, the Almighty, in allowing us to gather at this momentous occasion. Secondly, welcome to the International Teak Seminar, organized by the Faculty of Forestry, Universitas Gadjah Mada, supported by the Japan International Research Center for Agricultural Sciences, JIRCAS, and Perhutani, the state-owned forest enterprise. We extend our warmest greetings to all attendees. The theme of this international seminar is Improving the Clonal Teak Plantation for Sustainable Management of Monsoon Forests. As known to all of you, teak is recognized as one of the most valuable premium woods in the world. Naturally inherited desirable wood characteristics such as lightness and durability, hardness and stability, straight grain and workability, beautiful grain pattern and golden color, termite resistant, etc. are major attributes to teak to be a versatile timber for various uses. Teak plantations have been established in regions beyond their natural habitat, spanning 2 continents including Asia, Africa, Latin America, and some Pacific islands. However, the establishment of this plantation did not always involve the use of improved genetic materials and good silvicultural practices, resulting in poor productivity and quality. We anticipate that this seminar will offer novel perspective on the sustainable management of teak forests across all nations, with a particular focus on ASEAN. The seminar program covers 2 days session to discuss around 30 papers from many topics. It has genetic and tree improvement, silviculture, agroforestry, forest management, forest health, wood technology, and others. And 1-day field trip to visit genetically improved teak clonal forestry in Ngawi Forest District of Perhutani, located in East Java Province. It is about 125 kilometers from Yogyakarta. The information presented at this seminar proved to be invaluable to us. It featured keynote, invited, and volunteer speakers from several countries, including Japan, Thailand, Laos PDR, Philippines, and Indonesia. Today we notice here that there are more than 50 enthusiastic participants. Ladies and gentlemen, I would like to inform you that Professor Dr. Muhammad Naim, one of our invited speakers, an expert on tree improvement and silviculture of teak in Indonesia, and the project leader of SATREPS from Indonesian side, currently temporarily should take a rest due to illness and cannot join us today. We do hope he recovers soon. Amen. Finally, I sincerely thank you for your contribution to the success of this seminar. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Sabto.
The Honorable Distinguished Speaker, ladies and gentlemen, the opening ceremony of International Teak Seminar is going to be commenced by an opening address. We would like to invite to Vice Dean for Research, Community Service and Cooperation, Faculty of Forestry, Universitas Gadjah Mada. Please welcome Professor Insinyur Widiatno, SHUT, MSc, PhD, IPM.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. on behalf of the Dean of the Faculty of Forestry, UGM, let me begin by giving you a warm welcome in the Yogyakarta to all the honorable guests. First, Bapak Dr. Bambang Supriyanto, as the Director General of the Social Forestry and Environment Partnerships, Ministry of Environment and Forestry of Republik Indonesia. Ms. Ratih Listiorini, Master of Economics, representative of the Director General of Nature and Resource and Ecosystem Conservation. Professor Dr. Nokitani, as the Chairman of the SATER project and all the team members of the SATER projects, and JIRCAS, and all linguistic researchers from Japan, including Professor Dr. Yoshiko Sumura from University of Tsukuba, Japan. Dr. Sompon Kompo from Royal Forest Department, Thailand, and all researchers from Thailand, including Dr. Benjarat Propens and Dr. Komsak Wan Thong Che from Kasitat University, and also Dr. Laksame Suti Wilatiretana, and then Dr. Fong Filai, Forest Science Research Center, Lau PDR, and all researchers from Lau PDR, including Dr. Simon Phang Kam Ho, and then all of the invited speakers and also participants of the seminar that I cannot mention one by one. Alhamdulillah, let's first praise to be Allah Subhanahu wa Ta'ala, the Almighty, who give us the permission to meet in this seminar. Thank you for each and every one of you for being here today at the wonderful place. It is such honor for us having you in this seminar. I regret that our Dean, Dr. Sigit Sunarta, cannot join today because he has meeting in the Jakarta. In this opportunity, I would like to express my appreciation to community, especially to the Department of Silviculture, Forestry of Faculty, and then the Dies Natalis Committee for organizing this event, to all the sponsorship who generously help us to make this seminar coming true. In today's seminar, I would learn the start of the art of the clonal teak development, especially in the Southeast Asia, and hopefully we come up with a strong finding to improve sustainable forest management, especially of the teak plantations. In these regions, the teak plantations have been important in supplying timber for industry since the late 19th century. Faculty of the Forestry was born in 1963, is well known as the teak ecologic campus, since the subject about the teak is very pervasive in our curriculum in this research development. And also we have the long history about the development of the tree improvement, collaboration with the Perumperutani and the Ministry of the Environment and Forestry, how to improve the teak plantation in Indonesia, become higher productivity, and also can contribute for the local people, because mainly teak plantation in Indonesia is established by the agroforestry system. And then the advance of the tree improvement in the recent decade has led to establish of the clonal teak forest using the intensive silviculture techniques since the early 20th century. And then I think thanks to the Prof. Naim, who is the consistent leading in these subjects. The last 2 decades, we have provided the ample research and huge report of many aspects of the clonal teak plantation, including silviculture, forest product technology, forest management, forest conservation, and also social forestry. I believe that this seminar would result the advance in the research and innovation of the clonal teak plantation in future, and we hope we can frequently organize as the series of the teak conference to improve our forest become sustainable in futures. Well, I don't want to make too much of your time. I would like to express our thank you for participating in this important events. In the name of the Allah Subhanahu wa Ta'ala, the God Almighty, I officially open this international seminar on improving Clonal Teak Plantation for sustainable management of the monsoon forest. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Vidi, for the opening address.
Ladies and gentlemen, we cordially invite to the podium Director General of Social Forestry and Environment Partnership, Ministry of Environment and Forestry of Republic of Indonesia, but we would like to read his short CV first. He was highly educated and awarded a PhD in Management of Land and Forestry and Master Degree in Forest Policy and Planning in University of Gent, Belgium.
And he was convinced to play some important roles in Ministry of Environment and Forestry, such as Head of Planning Bureau, Director of Research and Development for Social Economic Forest Policy and Climate Change Center, Director of Utilization of Environmental Service of Conservation and Protected Forests, and Head of Gunung Halimun Salak National Park, Ministry of Forestry.
Please welcome Dr. Insinyur Bambang Supriyanto MSc to deliver the presentation.
Thank you. Good morning, ladies and gentlemen. It is really great honor to be here among all of you in the international seminar of the Teak Forest Plantation. I do hope that I can share to all of you about the agroforestry development in Java, particularly Indonesia in general. Teak forest plantation in Indonesia consists of 1.7 million hectares, or 31 of the global teak plantation in the world. And mostly those 1.7 million hectares are planted in Java Island. Until 2021, those teak forest plantation managed by Perum Perhutani, the state forest enterprises. However, in the year of 2022, there is new policy in Java Islands and what we call as forest area with special management. In Indonesia, what we call as KHDPK. Because Professor Naim visited me and asked me to deliver my presentation related with the new policy and also the prospect of this policy to the social, economic, and ecological impact if this system implemented in Java. So that my outline presentation will be two parts. The first is about the new policy of KHDPK, and the second is what we call as new strategy of the community teak agroforestry management through, this is very new, integrated area development for the social, economy, and ecological impact. Ladies and gentlemen, shall I start with the first? This is the new policy of the KHDPK. The total area of the Java Island, this is 2.4 million hectares. However, 60% of the population located in Java, very densely populated. That's why our forests, teak forests, under pressure by the community. We have at least three facts from the data, national data. The one is related what we call as poverty. 14 million people live in Java Island. They live categorized under poverty line. That is live inside or nearby to the forest. This is really big challenge for us. And the second, there is big incident for the flooding and also landslides. This is related also with the current situation of the forest in Java. And the third, This is very important to be noted, and the big challenge for us. From 2.4 million hectares, 4.72 thousand hectares under critical land. This is the background why we need new policy of the KHDPK. So let me explain first about the criteria and indicator. So Java Island now is divided into two management. The one is under Perum Perhutani, still going on, but the area is very productive. So we want Perum Perhutani still continuing the teak plantation forest with the professional activity, and then also neglecting the difficult thing in Java, like degraded land, should be restored by the government. And then the public settlement, public facility and settlement should be resolved by the government through agrarian reform. And then the tenural conflict also should be facilitated by us, by social forestry. That's why, ladies and gentlemen, so 2.4, 1.1 million hectares now is under the government to resolve the difficult things. They are like how to restore degraded land, and then how to solve the conflict resolution with the people, and also the last and not but least is about how to rehabilitate. So we ask again for the Perum Perhutani focus professional to the teak forest management in Java. This is the idea why KHDPK happened. And then the new policy, this is put it in the government regulation number 23, 2021, and then followed by the decision of the minister, my minister of environment and forestry, number 287, and then KHDPK consists of 6 purposes. The area 1.1, this is for the social forestry, and then for the rehabilitation, and then resettlement, it should be under agrarian reform, and then protection and environmental services. And the management itself for the Java, we have what we call as Ministry of Forestry Regulation number 4, 2022. So this is very new here. Ladies and gentlemen, let me continue to the second part of my presentation with the new strategy on community agriculture-forestry management through integrated area, social, economic, and ecological impact. So at the moment, from 1.1 million hectares, we already distributed to the community farmer group. This is about 400,000 hectares. And then 4,000 hectares, there are at least 162 farmer group manage this area. And unfortunately, only 140, the social forestry business group with the teak plantation, only 10% in Java Island. This is a really big challenge for us. So in Yogyakarta, we have 45 farmer group dealing with the teak. And I'm going to share to all of you the successful story of the teak management in Yogyakarta. And our approach is what we call is integrated area development. Why? Because of, social forestry consists of small area. We give only 20, 25 until 500. This is the maximum. And then one household, 2 hectares, very small. Sometimes, 2 minutes sustainable harvesting is not enough. That's why we need what we call as integrated area development, which enable to promote what we call as sustainable forest management. Yeah. I give you the benchmark. This is already success story. You can go there 1.5 hours from here. From this city, only 1.5 hours. You can go there, check what, the fact of my presentation. Okay, shall I start? This is Gunung Kidul. Actually, the EAD means we are going to create one region with 1 or 2 cluster of the community of the agroforestry. In that area, we use teak plantation, mahogany, and sengon. I don't know in English. Sengon is fast-growing species. Yeah, fast-growing species. 7 years, they can be cutted. And then why we merge 45 small region into one cluster? Because of, for the region management system, which enable to cut every year to fulfill the industry, industry requirement. So this is the idea, the scale of the economic and also the added value. We establish what we call as community-based industry. So sawmill timber, this is we established over there through what we call as a cooperative. Yeah, there is one Manunggal. The example is one Manunggal cooperative, one cluster, 12 villages, 45 type of the social forestry. This is community forest and community timber community, and how many farmers involved? This is very surprising. 8,500 farmers involved. So can you imagine 8,500 farmers and the total area only 3,577 hectares. What is the social impact? This is very important. One, the cluster region have a cooperative. This is the cooperative is like a company law. This is the most important. At least there are 5 important of the social impact. The one is the member, 8,500 farmer can make a negotiation. What is the right and what is the obligations in terms how to operate the cooperative. This is the one. And the second, this is very important, is to agree what they call as joint management plan. This is for the timber, yeah. What kind of the species? Okay, because there is a market, so why don't we select teak and then mahogany and sengon, and then we put it as as a main of the agroforestry for the timber. And what is the below? Yeah, below of the timber, they select like a crop. There is like soybean, and then crop apa namanya jagung, corn, yeah, corn, and also empon, like a spices, yeah, spices. This is grown under the canopy of the timber. And the third, this is resolving internal conflict, because 8,500 farmer, they have so many interests. So we assume that the cooperative can resolve their problem by themselves. And the fourth, because the cooperative can also make agreement with the off-taker, yeah, for the company who take the raw material of the teak or the process of the teak of the product. And the 5, this is public fund management, cash flow regulation, and also profit sharing. Okay, ladies and gentlemen, and then what is the economic impact? This is very important. The community-based forest management now is already licensed under FCS certification. It means the forest, agroforestry already managed very well by the community. So they have also product under, the type of the product like a log and process timber. And then the industry certification, they have a like chain of custody of the certification. And then also the product certification, they have FSC forest management, SVLK. And then the product capacity like a log 1,400 cubic meter, and the process sawn timber 700 to 1,000 cubic meter. And types of the wood, this is teak, mahogany, and acacia, and jungle wood. And last but not least, this is about industry partner. This like Indotama, Omicron, CV Quas, and then also CV of TGA. So the economic impact, this is with the cooperative actually. When you take a look, If we sell the raw material of the log, this is less price, less added value. So maybe, for example, like a teak, without industry, they only earn about 10 billion rupees. And with the industry, like sound timber, yeah, like a wooden board, and also wood pellet, the earning is about 17 billion. So there is an added value about 6 billion rupiah. This is about a teak. And also about sengon, this is about 5 billion rupiah. And also mahagoni, 6.7 billion rupiah. So in total, this is the added value of the total is about 18 billion rupiahs. And when we calculated annual income, become monthly income per capita, monthly income per capita without industry, this is about 778,000 rupiahs. If we compare with the poverty line in Gunung Kidul, this is about 350. It means already 2 or 3 times higher. They live already prosperity, not under poverty again. This is very interesting example in Gunung Kidul teak forest plantation. This is very important. Yeah. Last but not least, this is how the impact of the ecological. So we analyze from the satellite image of 2012 compared with 2022. Yeah. And then there is very interesting phenomena, yeah, about the plantation forest, dryland farming, and also mixed dryland farming. So the dryland farming and mixed dryland farming, this is actually agroforestry, juvenile of agroforestry. When we take a picture, this is still, still young, look like, mixed agriculture. But after 4 or 5 years, they already grow and there is no space. Corn and soybean could not grow anymore. Only empon or spices can grow over there. This is become a plantation. So if you can see here, between 2012 and 2022, there is no significant dividend, almost the same. It means we already adopt sustainable forest management. Yeah. If you cut, they will down the biomass, the forest cover. But if you plant again, so the forest cover will be remain the same. This is based on our research. Yeah. This is graphically like this. Yeah. So why the forest cover is still exists, remain constant? Because there is very simple the answer. We take a look why this has happened. Once the community already trusted by the state to manage their forests, it means they already put the social investment over there. Once they get benefit from that forest, it means they will protect by themselves from the illegal logging and then illegal mining and also illegal fire, forest fire. So this is why this is very important. Once again, the community is very important in terms of the agroforestry. Last but not least, this is the forest cover. This is, I will show you, the pink one. This is already, this is the pink, and then become yellow. Yellow, it means this is forest plantation, forest teak plantation. But the pink one, this is still dry, still young, juvenile agroforestry. Okay, this is ecological impact. Next, please. This is, you see the forest cover. I compare 2022 and also 2015. As conclusion, this is the last my presentation. With this project in Gunung Kidul, at least there are 3 conclusions we can meet with the teak forest plantation. The one is the community is getting more cohesive and unified. And the second, through integrated area development and cooperative, the economic condition of the community around the social forestry area has improved through negotiation to get suitable price and also added value of the teak product from the industry. the income 2 or 3 times higher if we compare with the poverty line. And the third, this is about social forestry, provide sustainable forest management, field business work for the surrounding community, including outside of the business group member, which enable the forest cover remain constant. So recommendation, this is my recommendation and also my hope to all of you, the expert. Teak is not so interesting for the farmer because of duration for the harvesting. Can you provide? In Gunung Kidul, only 10 years with the copy system. Yeah, copy system. When they cut, and then there are copies, and then with the pruning, they select only the best terubusan ya, the best tree remain, and then 10 years, we are waiting only 10 years, and then we will have 15 cubic meter a hectare. But again, can you provide with a good clone seedling for the teak? And then I will invite you, because I have 1.1 million hectares in Java, like a benchmark with a multi-layer, maybe teak, and then with kayu putih itu apa Pak in English? I'm sorry, I forget. Yeah, with the kayu putih, and then maybe with the soybean or corn. Then we hope that our farmer, their livelihood, they can earn, weekly income, monthly income, yearly income, and also for the long-term income. This is thank you very much.
Thank you very much, Dr. Bambang, for the very interesting presentation.
And it is the honor of us to have a presentation from the head of the Subdirectorate of Species and Genetic Utilization, Ministry of Environment and Forestry of Republic of Indonesia. But we will read her short CV first. She was highly educated and awarded a Master of Economic Development in double degree program of Ritsumeikan University, Japan and University Pajajaran.
She was convinced to play some important roles in Ministry of Environment and Forestry, such as the Section Head of Species and Genetic Utilization, Policy Analysis Junior Expert, and now as the head of the Subdirectorate of Species and Genetic Utilization. Please welcome Ibu Ratih Listiorini Eshut M.Ec.M.A. to deliver the presentation.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning, everybody. First of all, I would like to express my gratitude for the Gajah Mada University and also Bapak Dirjen, Pak Bambang, and all the presenter and also all of the participants in this seminar. I also would like to express apologies from my Director General, Bapak Profesor Satyawan. And this presentation, I would like to present about the forest biodiversity and management in Teak Plantation. Next. Sorry. Okay, and as we know that Indonesia has many biodiversity, all of this country, and we have more than 720 species of mammals, 1,606 species of birds around all of in Indonesia, and also we have 1,200 248 freshwater fish, and also we have 385 species of amphibians and many more species that have not been identified in various remote area in Indonesia. Recently, we also found the new species in Indonesia in Kalimantan, and the name of this species is Hanguana siti nurbayai. And also we found the new species in Papua. We have orchid, Bulbopilum wiratnoi, and other species that still identified by a researcher in Indonesia. As we know that the biodiversity has the important role in ecosystem, that the biodiversity include the genetic diversity, species, and also the ecosystem is the foundation of the human existence and well-being, and also protecting the people from natural disaster, regulate the climate, provide the fertile soils, and also human need for food, health, energy. And we know that the TIC has the has the environmental services, and also preserving biodiversity is the key to achieving sustainable development and economic prosperity. We also has the genetic that also has the role for the ecosystem, and biodiversity must be seen as not only as the cost center, but we must see the biodiversity as a profit center, and the biodiversity as an asset for the national economic development. And for the biodiversity conservation, we have 3 levels for the conservation. Ecosystem management, how to integrity of the ecosystem and also the protected area in Indonesia, increasing the species population, such as jalak Bali, badak atau rhinos, and also the other species. We also the management for the genetic resources conservation, that this is the new management that we have the program prospecting and also the sustainable use for the genetic resources. And from the Convention on Biological Diversity, from the Kunming-Montreal Global Biodiversity Framework, global goals for the 2040 is the living in harmony with nature, and we have the 4 goals. Goals A is about the ecosystem, species, and genetic diversity. Goals B about the nature contribution to the people, how to manage biodiversity that they can contribute to the people. And also goal C is about the benefit sharing, how the biodiversity and also the sustainable use of the biodiversity can deliver the benefitnya from the monetary and also the non-monetary benefit from this utilization, also share fairly and equitable to the local community. And also the goal D is about the means and implementation, how the including financial resources, capacity building, and also technical and scientific cooperation can deliver to the developed country. And how about the target for the Kunming-Montreal Global Biodiversity Framework from the Convention of CBD? We have a target 23 target, and the target is divided into the three sections. The first one is reducing threats to the biodiversity, and we have the 8 target, meeting people needs through the sustainable use and benefit sharing. And the last one is tools and solution for implementation and mainstreaming the biodiversity. And how about the national regulation? We have Act number 5, year 1980, about the conservation of natural resources and ecosystem. And we divided into the 2 sections, preservation of wild fauna and flora. This is based on the regulation number 7. And the utilization of wild fauna and flora, this is based on the regulation number 8, and how to the utilization of wild fauna and flora is with the principle, sustainable principle, also traceability and legality. And we have the principle that the sustainable use of this wildlife is based on the scientific to ensure that this regulation is not detriment for the population. And this is the national policy about the biodiversity, how to environmental protection and also the management, and the biodiversity mainstreaming. And in 2023, we have the presidential instruction number 1 about the mainstreaming biodiversity conservation to cross-sector policy makers. And this presidential instruction is the how biodiversity mainstreaming, all of the stakeholder can contribute to how to mainstream the biodiversity and also the how to conserve the biodiversity. And the last one is about the Ministry of Environment and Forestry instruction number, and also the number 1 in 2022. This is the instruction is about how to protect the wildlife from trapping and also poaching activity inside and also the outside forest area. And how the wildlife distribution in Java Island, and this is the distribution of Java Island from the analysis in my directorate. And in Java Island, we know that we have also a high biodiversity, not only ecosystem, species, but also in genetic level. And how the protected species and also not protected species still manage with the based on the regulation, and until now the discovery of new species is still occurring. And how about the teak? This teak is non-native species, as we know that this is originating from the tropical regions, and based on the minister regulation number 106, this species is not protected species. And also based on the CITES, Convention on International Trade in Endangered Species of Wild Fauna and Flora, this species in non-appendix CITES. So the utilization of this species is not based on the regulation regarding with the Minister Regulation number 106, and also doesn't comply the CITES. In Indonesia, teak is extensively cultivated in the region of Java because the soil is the level conducive for optimal teak growth, and also as high quality and has been a cornerstone in Indonesia export, especially in the furniture industry. So we know that the teak is only for the furniture industry. But we know that in teak forest, we have also the wildlife, or the teak forest is also the habitat for the some wildlife. For example, bird and also mammals, reptile and also amphibian. In teak forest, we also found the butterfly and the bees, spider, and also the microorganism like fungi, soil bacteria, and other microorganisms. But we also found that the protected species also found in teak forest. For example, muncak atau kijang, green people atau merak, and leopard. And we know that the teak forest only give the economic potential only for the furniture and also the other raw material, but we know that teak forest has the leaf that has the genetic resources that we can improve to the potential bioprospecting. We know that Java ethnic has the local wisdom to use the leaf of the teak forest, teak leaves for the rice wrapper. and also food preservation, because the leaf has the alkaloid, saponid, and tannin. Also, the leaves has the contribute to the medication like the asthma, and also prevent the cacing piperazine citrate, and also a diuretic effect, phenolic, antioxidant, and also hair growth and antifungal. This is from the research by the some the researcher that show that teak not only give the economic benefit only for the furniture or raw material, but also teak has the genetic resources that we can improve, we can elaborate that this is the potential bioprospecting to improve the genetic resources in the leaf of the teak. And these challenges this is important to ensure that the management of sustainable use and preservation in teak plantation, that we have know that the teak plantation also a habitat of the wildlife. We found the merak and other species, and also develop key synergy, scientific, media mass, government, business, then also community, and potential economic from the non-timber utilization, like the bioprospecting. We know that the leaves of the teak has the genetic resources that we can improve to the bioprospecting for medicine and also other use. And there is a need for innovation to create the teak variative with a certain life cycle, with maintaining high quality, aiming to store the growth of the teak. This is the end of my presentation, and thank you so much.
Bu Ratih, please remain on the stage first. We would like to re-invite Dr. Bambang Supriyanto to the stage with us, because the organizing committee would like to present token of appreciation to the keynote speakers.
And we re-invite the Vice Dean for Research, Community Service and Corporation of Faculty of Forestry, Universitas Gadjah Mada, to present the token to the keynote speaker. Dr. Bambang, Prof. Vidi, and Ibu Ratih, please remain on the stage. Ladies and gentlemen, next we will take this opportunity to be documented. We will have a group photo session, so we invite to the stage all eminent resources person and also all participants to have a photo session together on the stage, please.
Please, all the participants can join us. Again, we invite to the stage all eminent resources person, all participants, to have a photo session together on the stage, please.
Mas Andi, Mbak Nisa, could help us to arrange the position and ensure that everyone fits into the frame? Di kanda sini. Kanda mana? Kanda. Mr. Kanda, please join us to
Aman.
All right. Please give your best smile, ladies and gentlemen, for the photo.
1, 2, 3.
All right, again.
Another pose. 1, 2, 3, and say Jogja. Once again, cheese. Okay, thank you very much. And ladies and gentlemen, before we go to the first session, please enjoy the coffee break that has been prepared and served at the corner. We will start the first session at 10 a.m. Thank you. Ladies and gentlemen, while you are enjoying the coffee break, we are going to start our first session. Allow me to invite our moderator who are present here. She is one of lecturer on Silviculture Department of Faculty of Forestry, Universitas Gadjah Mada, with research interest of forestry improvement, forest genetic, forestry propagation, and silviculture. And she was passed her doctor program from Tsukuba University, Japan. And please be invited to the stage, Dr. Sawitri Eshut, MSc. I will hand over the session to you.
Okay, thank you very much for the time given to me. Good morning, everyone. Welcome to today's presentation. So, I am Sawitri and I'll be the moderator in this session until 12 p.m. this afternoon. And now, allow me to welcome the speakers and please come and sit in this stage. So in this session, we have 4 invited speakers. The first speaker is Dr. Sabto Indrioko from Indonesia. Please come to the stage. The second is Ms. Somporn Kum Chompo from Thailand. Please come to this stage together with Mr. Sabto. The third speaker will be Professor Dr. Naoki Tani from Japan. And the fourth speaker is Professor Yoshihiko Fumura from Japan. Let's give applause for them. Thank you very much. Please, you can sit. Yeah. So before the presentations begins, let me inform how the presentations in this session will be going on. The first, all speakers will be invited to present the materials, and then please present your material in 20 minutes. And then after that, there will be question and answer in the last 30 minutes in the session, end of the session, and followed by discussion. Ladies and gentlemen, the invited speakers in the first session will present about the clonal forestry systems and plus tree selection intake. So without further ado, let's get started with the first speaker. So the first speakers will be Dr. Sabto Indrioko, and let me read his curriculum vitae. Dr. Sabto Indrioko got his doctorate degree in forestry science, Institute of Forest Genetics and Forestry Breeding, University of Göttingen, Germany. And now he is a lecturer and head of Tree Improvement Laboratory in the Faculty of Forestry, Universitas Gadjah Mada. And his research interest is in tree improvement, ecological genetics, and genetic resources conservation. And now, in this moment, he will present about the tree improvement program of Indonesia STIC. Dr. Sabto Indrioko, time is yours.
Thank you, Dr. Savitri. Please let me stand up. I want to present about this tree improvement program of Indonesia STICS. May I go down? Okay, thank you. Distinguished participant, I want to share about the tree improvement program of Indonesia STIC. This paper is written by me and also with Professor Muhammad Naim, together with Aris Wibowo from Perhutani. We know that the tree improvement program always consisted of several stages. And first of all, we always started with page population. We collected plus trees according to the purposes of the tree improvement, and then we go to the next step, call it, we make genetic testing with breeding population. And then the tested of the result of the testing, we use it for the propagation population, and we can use it as material for plantation. And if we want to get the kinetic gain, in order to optimum the kinetic gain, we should start with broad genetic base, because we make a selection for the next step. And then the representation of the genetic diversity in this case is very important. And also the intensity of the genetic selection. The more intensifier, the more intensity will make a shorten of the genetic variation. But we have more genetic gain. That is the consequence. And if we, sorry, I want to go to next, please. Okay. But as you know that Indonesia is not the part of the natural, not the natural distribution of teak, because the natural distribution of teak, we know that it consists of India, Myanmar, Thailand, and also Cambodia, and Laos. So how to increase the genetic base in Indonesia? I want to say about that in Indonesia we have only, we call it only land race. Next, please. Okay. You know that in not in 19, but in around 17th century, Dutch come to Indonesia, and then they know about the abundance of teak in Indonesia, and then make monoculture management of teak started around 17th centuries. They make they develop the management in order to maintain it sustainably. And then the effort of the tree improvement, next please. The effort of the tree improvement was marked by International Teak Province Trial. It was established in 1932 in four locations. One is in Bojonegoro, is Java, in 1932. There are some provenances from India, and then from Myanmar, also from Laos. There's different characteristic, and also from Indonesia. There are 5 land races, and then 3 types of ticks. And based on the previous result of the research, it is said that from Malabar, India, is the best performance. And then what we call the next era after Independence Day of Indonesia, the management of teak is controlled by Perum Perhutani, a state-owned enterprise in Java. Next, please. And we have a collaboration, Max, thank you, between UGM and Perumburu Tani. We make exploration in order to make broaden genetic base from Java and out of Java. We collected around 600 plus trees, 200 from Java and 400 outside from Java, in order to make sure that we collected from all of the part of land races in Indonesia. And then we collected both generative and vegetative materials. And as you know, and from these small islands, we use small boats, and also with big ship when we went to the very far island. And then, in order to conserve the genetic material, we collected as arboretum. We have 32 types of ticks, including also 3 species, Tectona grandis, Tectona hamiltoniana, Tectona abundans, and several types of tick. And then we make a clonal bank. All of them were saved here. And we also built a conservation garden from all of land races. So this is a source of germplasm. Its existence must be maintained and also developed. This is just an example when we have established the Tectona abundans and Tectona hamiltoniana. And then for the genetic material, we plan as progeny tests, and then we make selection, and then genetically racking. We make we cut the and then we left the 1 tree plot for seed lot for the best performance. And then the plantation will be used as seedling seed orchard after this plantation has sufficient fruit production. This is one of the example of the seedling seed orchard. It's consisted, you know that the performance is better with the strictest already improved. And when we use it as a propagation population after it has already produced enough fruit. And then we have also collect the vegetative material, and we test as a clonal seed, a clonal test, and then the best performance from this clonal test, we make it as a hedge orchard. And also, we prepare also the clonal seed orchards, and then based on the progeny test, we make a selection and cut the worst trees and make it as a clonal seed orchard for production seeds. So, yeah, I want to describe what the breeding strategy for clonal forestry. We have collected the plus trees, and then we test the sprouting ability. And also the rooting ability. We know that after we collected around 600 plus trees, only 1/4 that can successfully sprouted and rooted. And then we make a clonal test. After that, the best clone, we make it as a propagation population and build it as commercial plantation. So this is an example. And also Professor Ganis, I have your photo here with the best clone of the, and then you know that this is the uniform of this stand of the best clone. We have this photo is taken in 2014, I think. Okay, this is the comparison of the various genetic materials. The left side is from seed producing area. We have observed in 10 years old, and then the stands from we have established from CSO, from clonal seed orchard, and the right side is from head orchard. So we can get genetic gain until 83% in compared to the stand built from seed producing area. You know, there's the crooked stand is from the seed producing area, and the straight trees is from head orchard. So it is because we have high selection intensity. This head orchard produce only from two the best clone we have selected. So the performance is better, but we have to know that the genetic variation is very small. So there's also the comparison about the growth, and also the pollutant penetration is better if we compare from clone in compared to the stand established from clonal seed orchard. So the clonal stand has better growth and similar wood quality to the non-clonal stand. And also this, the quality of clonal teak wood is also increased. If if we compare, if we compare from different age, it is better, but from the quality, you know that this is younger, so we have to wait the quality, but the growth is already increased. So the 3H influences the increase in the durability class and the strength class of teak wood, and also influence the increase the percentage of teak hardwood. This is the result of the clone we have planted in 2002, and then we have just measured. It is already about 48 centimeter, the diameter, the basal diameter. And you know that this hardwood is already also increased, and the age is around 21 years old. So it is already increased, the hardwood. Okay, this is okay. You know that this is the prospect of the clonal forestry. So this plays a crucial role in enhancing forest productivity, and also this has the potential to increase the genetic gain, growth, and uniformity of teak stand. But we have to take care about the number of these safe clones. We have to increase the genetic variability. And then this is the future challenges regarding the genetic materials. We have to anticipate the impact of environmental changes in the future. So we have to increase also the genetic base of the ticks in the future. We have to broaden the genetic base, and also we have to take care about the conservation of the genetic resources. As you know that we have already only 2 clones in the area that we have already developed from the selected material. I think I have already finished my presentation. Thank you very much for your attention.
Thank you very much, Dr. Sabto Indrioko, for his presentations. So from Dr. Sabto Indrioko, we know that actually the tick breeding program in Indonesia has been started long time ago, and nowadays Indonesia already established or developed 2 clones that we called as miracle clones and planted in large scale. Okay, thank you very much, Dr. Sabto. And how about the tick in Thailand? So let's call Miss Somporn Kumchompo to share the breeding program of tick in Thailand. Miss Somporn will present about the 3 improvement approach for tick of Royal Forest Department in Thailand. And in 2013, he is a scientist in Department of National Parks, Wildlife and Plant Conservation. And from 2013 to present, now he is working in Royal Forest Department in Thailand. Ms. Somporn, time is yours. 20 minutes, please.
Thank you. Good morning, ladies and gentlemen. My name is Somporn Kamchumpu. I'm new generation of tick improvement of Thailand. Today, I'd like to present the result of the Royal Forest Departments of Thailand on 3 improvement for tick. I want to share about the history of tick improvement in Thailand. Tick improvement research in Thailand began in 1957 and has continued for over 60 years. In the early year, we study work conduct on the genetic variation of tick in Thailand, to selection of party in pair province, and the method of propagating tick party in 1959. Tea budding method was developed by Professor Saad Bunkert of Faculty of Forestry, Ksat Sat University. Sorry. Tick improvement research in Thailand in 1965, a cooperation project between Thai government and Danish government established the Thai Danish Tick Improvement Center or TIC in Ngao district, Lampang province. In 2001, TIC was able to study plant traits from grafting or budding to cutting and tissue culture. TIC is currently known as Forest Research Center to Lampang and has established various test spots in addition to establishing various test spots. The Royal Forest Department is also working to create a new generation of tick researchers in various areas. This is because tick breeding is considered a work that must be carried out step by step and continuously. Royal Forest Department has conducted research tick improvement and a new generation tick now. Royal Forest Department has conducted research on tick improvement, planting, testing, and the production of high quality tick seeds. Research has been conducted in various fields of biology, ecology, and silviculture to create a multiple breeding population program. This program combines short-term and long-term breeding program to maximize breeding efficiency and is the easiest way to maximize the benefit of breeding. A vast overview of the program is shown in the diagram. The diagram shows genetic resources and show select for party. Party we have research molecular genetic in the future. Genetic resources in the early year, genetic resources were primarily collected from national forest and plantation over 20 years old. Party selection have method in Thailand. Criteria used for teak party selection are outstanding characteristics in many aspects, including about growth, stem quality, wood quality, healthy of teak. As present, party survey has selected 636 party were registered, but can be to accept in Khon Bank 511 party. Then the tea were planned in various forms. There is also to study of the teak international provenance Thai with detail of the teak plot of breeding as follow. We have Khon Bank, Khon Seed Orchard, Clonal Seed Orchard, Breeding Orchard, Clonal Taste, Progeny Taste. Khon Bank in Thailand. 511 party of the Khon Bank in 5 size. Clonal Seed Orchard, plant as distance of 3 by 3, 6 by 6, 8 by 8, 10 by 10, or 12 by 12 made into 6 sides. And okay, Clonal Taste Seed Orchard have the first world of Clonal Seed Orchard in Mecca Civil Cultural Station, Phayao Province, yes. And Breeding Seed Orchard have 200 party in 3 sites. We have backward thinning for improvement, 3 improvement, yes. Clonal Taste series. Clonal Taste is divided into 5 sets, is with 100 clone. 500 party into 7 sites. Progeny test conduct during 2008 to 2011 are divided into half-seed progeny. and Fusi progeny. This presentation will focus on the clonal test strategy, which is at the heart of BID work, which is an objective to one, to evaluate genotypic value of party by planting in the same environment. Two, to evaluate genotype and environment interaction effect on phenotype of party. The results from the test planting are: one, choosing super cone for clonal plantation. Two, reselect cone for genetic thinning in clonal seed orchard. Three, use data to select mating pair in Fusi progeny test. I want to show clonal test set 1. An example of success of Royal Forest Department clonal test set 1 plot in the genetic gain value to find the top 20 party for plantation population. Can analyze to find party with the best growth or hardwood growth in this population. New formative improvement program that will develop F1 strain to F2, F3 next. Yes. Royal Forest Investment has achieved success in teak improvement as follows. 1, 500 level party are the phenetic base of good teak. 2, clonal seed orchard that can produce seeds at 2 sites, namely Phayao and Khon Kaen province. 3, top 10 family from Fusi progeny test has the best growth potential and stem quality. 4, more than 150 family from half-seed progeny test for good new generation party for seeding seed orchard. Okay. In the future work, the goal is to develop teak that are 1, planting clonal test 5 sets of series 2 select from 20 top party clonal test from 5 sets of series 1. Series 1 have 100 party. 2, propagating teak as mass product of top clonal test and top progeny test by cutting and tissue culture. 3, create DNA molecular genetic database of 500 every level party. 4, develop as one breeding, better adapt to change climate condition. 5, eliminating their life cycle and testing variety of resistant to tick beholder. Okay. Finally, I, I have to thank you all.
Thank you very much, Ms. Somporn.
สวัสดีค่ะ
Okay, thank you very much, Ms. Somporn, for your presentation. And now we know that the story of successful of teak plantation is not only in Indonesia but also in Thailand. They also start from select the teak material from more than 600, and then they select until now they have around 20 top plus trees. Okay, and our next speakers not come from country that natural distribution of teak like Thailand, but let's see what Professor Tani would like to share with us. And he will present a material entitled Relatively Higher Narrow Sense Heritability of Hardwood Formation in Teak and Potential for Tree Improvement. Actually, Professor Naokitani is my professor when I was in Japan. He is a senior researcher in the Japan International Research Center for Agricultural Sciences and also one of the professor in the University of Tsukuba, Japan. And his research interest is in tree improvement of tropical tree bird species, genetic diversity and adaptation of tropical forest species, and also reproductive ecology and phenology of tropical forest species. Professor Tani, time is yours.
Thank you very much. Okay, thank you very much for this invitation and organization committee. Very good this international seminar. And thank you very much for the distinguished guests and also the attendees. So today I want to share with you about outcomes from our collaboration between my institute, JIRCAS, and the Royal Forest Department. I serve project leader of the Satoris project with Gajah Mada University and BRIN in Indonesia. But today, main topic is teak. That's why I want to share with you the result in Thailand. Okay, so today I want to share with you the result about the heritability of the growth and hardwood formation. So today's audience has a lot of background, but everyone study teak. That's why I want to I want to provide some lecture of the genetics from first. So please remember that this simple genetics about the heritability. So heritability means amount of the phenotype. This is we can observe the phenotype. This is, for example, shape of the tree and the diameter of the tree and the color of the trunk. This is a phenotype, all the phenotype. So this phenotype variation in the population that is attributable to the individual genetic differences means that phenotype is controlled by the genetics and the environment. The proportion of the genotype is proportion of the controlled by genetics. This is a heritability. So heritability has two types: broad sense heritability and narrow sense heritability. So broad sense heritability means this is a variance of the genetics and the variance of the environment. This is a total variance. So this genetic variance is divided by the total variance. This is a broad sense heritability. And then this genetic variance is separated into the three parts. It's a bit complicated, but please remember, this is additive genetic variance. This additive means this variance is transferred to the next generation. This is controlled by the allele in the single locus. And then this is the dominance heritability, means that this one is controlled by heterozygote. For example, we have a blood type, A blood type, AB blood type, B blood type, O blood type. For example, AB blood type is a heterozygote. This is one of type of the dominance. So if this phenotype is controlled by the heterozygote, we can separate it into this part. And this part is epistatic variance. This is a bit complicated, but for example, the diameter is various type of the diameter, This is a quantitative phenotype. This is controlled by many genes. If the many genes controlled by this phenotype, in this case, we can assign this epistatic phenotype. So we can separate. So this genetic variance is separated, and then we just focus on this additive phenotype, additive variance here. This is a narrow sense heritability, but this is very complicated. But this narrow sense heritability is very important for the tree breeders, because this additive variance can transfer to the next generation. That's why we can focus on the narrow sense heritability. This is very important for the selection of the next generation. So if we can identify the heritability of the hardwood formation in the growth in the teak, this is very important because this is a very useful information for the tree breeder, how we select good teak. Because if heritability is very low, in this case, in the particular phenotype, this heritability is very low. In this case, it's not so good for the goal of the tree selection. So enhance, if this wood formation heritability is very high, we can enhance wood quality, of course, durability and resistance. And also, maybe everyone agree, this economic value will increase. Hardwood is more expensive than the softwood. That's why we can increase the economic value, and also we can optimize breeding program, and also we can reduce environmental impact. And then finally, we can also enhance climate change adaptation, because hardwood and softwood proportion is very closely linked to the strength of the wood. We can create very strong teak plantation. So just now, the forestry Royal Forest Department explained that they have the clonal test in the three regions in the Thailand. We use one of the clonal test in the Kanchanaburi province. So in this clonal test, we collect the data of the diameter and the height in 2017. And also we can measure this gas is the diameter and the height in 2020. And also we can measure the subwood depth like this. We can use a borer, and then we can measure the subwood depth. And then if after we measure the subwood depth, we can simply we subtract from this subwood depth, we can estimate the hardwood diameter. Okay. Then for this phenotypic variation, firstly, we conduct how environmental factor affect this phenotypic data. So we conduct a spatial analysis. So you can see this is the data from the, this one is gas. This is the diameter of the 2020. Here, many individual is lower data, and here many individuals have higher data. This means that this is environmental heterogeneity in the plot. So we adjust, we reduce this environmental factor from the real data. And also this is the data from the height 2020. Here, a lot of taller tree is concentrated here. We also reduce this environmental factor. Then this is a subwood 2020. Here, there is a lower subwood depth individual is concentrated. We also adjust this data prior to the genetic analysis. Okay. Then this is after this adjustment, environmental adjustment, and also the normalization. we can find this distribution of the phenotypic data. So this is a diameter of the 2020. So actually the diameter, this variation is very narrow. And then this is a hardwood diameter of the 2020. You can see this is from -3 to 3, and the standard deviation is 0.970. This is much higher than the diameter variation. So that's why this is one of the indicator. The diameter of the hardwood is very high variation. That's why this is a very good target to select the cheek individuals. Okay. So then we conduct a genotyping. So at that time, we use a MIG-SEQ technology. Today, I have no time to explain the detail of this technology, but easily we can collect a SNP, single nucleotide polymorphism data. This is the SNP is simply we can identify the polymorphism, for example, adenine and thymine and cytosine, guanine, this difference, we can identify this genetic variation. So then, this is a mismatch distribution of this. We found 3,833 SNP loci, and then this is a mismatch distribution. Many of this distribution is concentrated here, but this is only that you can find this peak. This is just misidentification. So we exclude this data, and we use this data for the genetic diversity analysis. Then, in this clonal trial, we found that some individual has only one replicate. This is maybe the misplanting in this clonal trial. So that's why we just use this 94 clones in this in this clonal trial for the next genetic analysis. Then we estimate heritability, but there is some types of heritability. So if we know that this is a pedigree relationship, in this case, this is traditionally we estimate heritability using this method. In this case, this pedigree-based heritability estimated to estimate a covariance between the kinship. This kinship means that this relationship between the individuals, parental family relationship, and the phenotypic variation. And then, if we conduct the genetic analysis, we can estimate genetic difference between the individuals, and then we can estimate a matrix. We call this one as a genetic relationship matrix. So then we can estimate relationship, the covariance between this genetic relationship matrix and phenotypic variation. Then we can estimate the heritability. This we call heritability by the GRM. And then finally, another method is we can estimate genetic-based heritability. This one is if we have a lot of the genetic data throughout the genome. In this case, this method is much powerful. So if we measure this heritability in the same population, normally this pedigree-based heritability is lower, and then this GRM heritability is middle, and then genomic heritability is much higher. This result will be obtained. So today, we estimate the heritability of this genomic relationship matrix heritability. So to estimate a genetic relationship matrix based heritability, we have to estimate this GRM. So we use R package AGH matrix to estimate the genetic heritability. After that, we conduct we use a linear model to express to estimate heritability using the heritability package. Okay, so in this genetic relationship matrix, there is several times. It's a bit complicated. To estimate this matrix, we these two methods shows the additive genetic matrix. These two methods show the non-additive. This is a dominance, actually dominance genetic matrix. This is an equation, but this is complicated. I skip it. So if we use this one, we can estimate narrow sense heritability. And this is non-additive one. This is not narrow sense heritability. This is a dominance heritability. We can estimate this one. So finally, I can show you the result. So this one's, if we use more than 2 stems, and this one is one clone, we can find the clone stem more than 2, and within the clone, we can find more than 4. This is I estimate a 2 type, but this is not so different. Then this blue and red is additive heritability, and then green and purple is non-additive heritability. So this is the diameter of the 17 and the diameter of the 20, and this is the height of the 17, height of the 20. This is the subwood depth. This is a hardwood diameter, right? So the height, in the 70, heritability is very high, but in the 20, heritability suddenly drop, because in these 3 years, still in 2017, tree is growing up, and then this 2020, tree height become plateau. That's why there is no genetic variation. That's why heritability going down. But in the diameter, still 70, tree is growing up, but this genetic control is not so high. But 2020, this diameter difference is become large. That's why heritability going up. But this height, the heritability is large, but also subwood depth heritability is very, very high. So, and also the hardwood is not so high, but normally subwood depth genetically controlled within this phenotype. So if we add up this additive heritability and non-additive heritability is very, very large. That's why I think the hardwood formation is very important factor to control the genetic to do the tree improvement. So finally, I share some result of the previous study. This the 2009, this person published one paper. This also shows that the subwood heritability is very large, and also hardwood is very large. So that's why this is a very same result of our study. That's why I can conclude the subwood and hardwood formation is very good target to improve the chick in the forestry. Thank you very much for your attention.
Thank you very much, Professor Tani, for his new knowledge for us, because some of us here is students and also many lecturers, but not study in genetics, so your presentation is very invaluable for us. Okay, from Tani Sensei presentations, he underlined that the heritability is fundamental concept in genetics, and study on heritability not only important for growth only, but also hardwood formation that represent wood quality. Thank you, Professor Tani. And last but not least, we have one professor. He is also my supervisor when I studied previously. He is Professor Yoshihiko Sumura. And today he will present about the genetic diversity and adaptation of teak in Indonesia. Professor Sumura is a professor in Faculty of Life and Environmental Sciences and in University of Tsukuba. Previously, he is also director in Department of Forest Genetics, Forestry and Forest Product Research Institute. His research interest was in forest genetics, molecular ecology, and also conservation genetics. Previously also, he got awards from Yomiuri Prize of Agricultural Sciences and the Midori Academic Prize. Let's give applause for him. Sumura Sensei, time is yours.
Okay, thank you. Thank you very much. And I'm very happy to present our study in here. Thank you very much for inviting me to this seminar. Today I talk about the genetic diversity at the local adaptation in teak in Indonesia. Okay, then you know that teak is very important in this country. Then, oh, no, this one. Oh, this one. Because teak is widely planted in tropics because of this useful timber species and also the high adaptability for the wide range of the climate range. Then teak was introduced more than 100 years ago. Now we can see the many teak plantations in Java Island. Probably you well know than me. And then recently, but the plantation material is very limited. The Indonesian government selected a very good, nice clone. Then they planted in the whole of the Java Island. But probably we need the genetic information of the teak plantation material in this country. Then for the future tree breeding. Therefore, we need the genetic information for the planting material teak in Indonesia. Then why we need such genetic information for the planting material? In here, to understand the origin of the teak plantation material in Java Island, that is very important for the future sustainable forestry. If the genetic diversity become very small, sometimes inbreeding depression may occur, especially tree species. That means the timber production also may decrease. That's a big problem. And also to clarify the genetic constitution of the planting material in Java Island, that's also important for the future tree breeding. Then finally, to identify the adaptive genes for the different climate conditions is also useful for the future tree breeding, because now we have a problem for the global warming. Then sometimes the climate very change. Some area become very dry, but the other is very wet. Then we need to specific tree to adapt such a harsh condition. Therefore, we need genetic information. Okay. Then to clarify the genetic origin of the Indonesian teak, we use these kind of materials. First is the provenance test forest. That is the Safto already mentioned, and this provenance trial. This is a material from 3 populations from India. 1 population is Myanmar, 3 population Laos, 1 population Thailand. Then established a very old time. Then we collected the leaf sample to this provenance trial. Then extracted DNA. Then Indonesian material here, we use 9 Indonesian landrace and also the 28 plantation population cover the whole Java Island. Then we hired 2 kind of molecular method. One is the mixed analysis, which is the Professor Tani already mentioned. And that's a procedure a little bit complicated. I don't explain it in detail. But anyway, this method is very new. This is a multiplex ISL genotyping by sequencing. The recently Japanese groups developed this method. Then this method is very quick, easy to execute, relatively inexpensive, and also can be amplified even in small DNA, and also the low quality DNA we can amplify, because this is a PCR-based method. Therefore, this method is very suitable for example, endangered plants, endangered herb. If we cannot take a big sample, big tissues, we can amplify this method. Generally, the 100 to 1,000 SNP we can detect. Then another one is the RAD-seq method. This is the resection site associated DNA sequencing. This is very popular method. But we need a very high quality DNA, because this DNA digests by resection enzyme. That means we need the intact DNA. Then if we apply this method, we can detect more than 1,000 of SNP. That means the RAD-seq analysis, we can detect a much high number of SNP compared to mix-seq. Then after getting such a SNP data, we estimate the genetic diversity. For example, the number of allele and also the number of effective allele, the observed heterozygosity and expected heterozygosity fixation index, to compare the genetic diversity between Indonesian planting material and natural population. And after that, we also estimate the genetic structure using a software of genetic structure and principal coordinate analysis. And also we constructed a phylogenetic tree using a neighbor net or neighbor joining method. Then, this is a very important part, actually. Then we try to detect the candidate loci for the local adaptation. Then in this analysis, we hired two kinds of method. One is a PD test. PD test means the population differentiation test based on population genetic theory. Then we hired two software. This is base scan method. This is SNMF PD test. Then another one, gene environmental association test, that's a GE test. This is just association between climate variable and genotyping data. Very simple method. Then we hired this software, but both methods, sometimes we can detect a false positive. Therefore, after getting the result, we carefully check each result, and that gene is really adaptive or not. And then from this slide, I show you some result. This is a result of the mix-seq data. And actually, this study 8 international provenance trial and also 9 Indonesian land race. Then he conducted the mix-seq analysis. Then he got 459 SNPs. Then using this kind of SNP, he estimated genetic diversity between Indonesian planting material and natural population. This is the result of the mix-seq. The plantation material, just observed heterozygosity is 0.0075. Is also high. Then this is landrace, Indonesian landrace also very similar value, 0.0074. But natural population have higher genetic diversity, 0.177. That means Indonesian planting material genetic diversity very low compared to the natural population. That means we can import some other additional material from the native habitat. Then echo also the estimated genetic structure of the teak population. Then this is the teak plantation in Java is very different from the Indian population. Actually, this is the Indian population. Then another population is here. This is plantation in Indonesian landrace and Thailand, Myanmar, Laos. That means the Indonesian planting materials genetically close to Thailand, Myanmar, Laos, not India. Then within the Java island, the teak plantation is Java is divided roughly 3 groups. Western part of Java, central part of Java, and eastern part of Java. This is a result of structure analysis. That's the red color is the western part. Yellow color is the central part. That's a blue and yellow. That's mix. This is the east part of the Java. Roughly divided 3 groups. Probably this is a different planting material each region. Then from that slide, I show you the result of the RADSEC. Then we can get a high number of SNP. In this case, we got 8,951 SNP using the RADSEC analysis. They compare the genetic diversity between provenance trial and Indonesian landrace. Then just average number in the provenance trial 0.207. Then Indonesian landrace 0.175. Still, genetic diversity lower in the Indonesian landrace. But that difference is not so large compared with the mixed seg, because RADSEC data that cover the whole genome. Therefore, probably this value is a much real value compared to the mixed seg. Because the mixed seg, we just use 400 something. This is 20 times higher. That's a number of the SNP. Then we also estimate the genetic structure. Just the genetic structure of RADSEC data is more detailed than that of the mixed seg data. Then a new cluster appears. New cluster means this Thailand cluster and some of the Laos population. That's blue one. Okay, that's a little bit different from the mixed seg result. Then this is the result of the principal coordinate analysis. That also that result is very similar with the mixed seg data. It's not so big difference. Then this is a phylogenetic tree. The phylogenetic tree using the RADSEC data more detailed than that of the mixed seg data. And actually here is this Indonesian landrace. This is an Indian population. Then within this group, we expanded this area. This is the Indonesian landrace. This is the Laos population, Thailand. This is Myanmar. Then conclusion is the Indonesian landrace very close to Laos, Myanmar, and Thailand. Then we also try to detect candidate loci for the local adaptation. Then this is the result of the PD test. Then we hired 2 kinds of software. The base scan, unfortunately, we cannot detect any significant loci. But another test, SNMF-PD test, we can detect 981 loci for the for candidate loci for the local adaptation. Another test this is a gene environment association test, GEA test. This is I mentioned before. This is just association between climate variable and genotyping data. But sometimes the climate variable between the climate variable sometimes show the collinearity. Therefore, we excluded this climate variable. Then we pick up the 5 climate variable. This is the climate bioclim 8 means associated to the temperature. Mean temperature of the wettest quarter. This is the mean temperature of the driest quarter. This is the mean temperature of warmest quarter. Then we analyze each climate variable. Then we can detect this one, 52 significant loci. This is a 65. This is in 18. Then lower part, this is the associated with the precipitation. This is the precipitation with a wettest quarter. This is the precipitation with the driest quarter. We could detect the 3 and 8 significant SNP respectively. But there's no SNP commonly detected among the 5 climate variables like that. And this is a summary of the candidate loci for the local adaptation. We use 2 kinds of method. One is a GEA test, another is a PD test. Then this is a associated to temperature. We couldn't detect any common SNP in this analysis, but this one, for the precipitation, we could detect just 1 locus. That's probably a strong candidate locus for the local adaptation. But we need some more deep study in the future. This is a summary of my presentation. The Indonesian cheek are genetically very close to the Laos, Myanmar, Thailand, but genetic diversity lower than that of the natural population. The RADSEC data show the more detailed than that of the MIGSEC data. Then we could detect the candidate loci for the local adaptation, which could be used as a future planting strategy, but needs more deep study for the practical use. The final one, this is acknowledgement. That's it's Onuma. He is my PhD student. He conducted the RADSEC analysis. The ECHO collects the cheek material in Java. Then Professor Naoki Tani, he helps us RADSEC analysis. And Weedy Sapto and Professor Naim help our project. And then our budget money comes from the satellite projects. Thank you very much.
Thank you very much, Professor Sumura, for your presentations. Actually, maybe there will be many questions from the participants because, Professor Tani and also Professor Sumura talk many about the genetics. So I hope it will open our mind about the genetic, and also there will be many questions for further information. Okay, ladies and gentlemen, all the speakers already gave their presentations, and now it's time for the questions and answers. So in this time, I'd like to have 3 participants. So if you want to ask questions or you interest with some presentation that presented by our speakers, please raise your hand and also mention your name and institutions. The first questions. Okay, the first questions is from Mr. Fongvilai. No? Oh, Simon, sorry, okay. And then the second questions from Widi and Prof. Widi, and once again, okay, from Prof. Rahayu. Okay, the first questions from Mr. Simon, please.
Yes, thank you for you have a very good presentation. So I'm Simon. I'm working in the National Agriculture and Forestry Research Institute, Lao PDRs. So my first question is for Dr. Sapto. So you mentioned that the clonal ticks, the new clonal tick is really grow well. I would like to ask you about the environmental factor. Is the influence on the new clonal or not? If we compare with the original one. Thank you.
I'm sorry, but would you please to louder, please? Yeah.
I would like to add about the environmental factors influence on the new clonal ticks. That you say that is really have the good growth in your tree size, your trail size. Thank you. Can you get the meaning?
Thank you very much for your questions. The second questions from Professor Widi.
Thank you, Dr. Savitri. First, I think Dr. Sabto already explained about the what I call it, the process of the improvement in Indonesia, and then now in the clonal forestry in Indonesia, we use only 2 clone for the large-scale plantation. And then, what do you think about the future, about the genetic diversity? Because Prof. Sumura said that one of the important to maintain the productivity, genetic also is important. Genetic diversity is also important. So, what is happen if we use the only 2 clone for the large-scale plantation in Indonesia? And then the second question for Dr. Benjarat Propens. Thank you for your sharing information about.
I'm sorry, Prof. Widi. Miss Somporn.
Oh, sorry. Yeah.
Okay.
Thank you for your sharing information about ticks, development tick in the Thailand. And then you know that what is the impact if we already use the, what I call it, like selected the clone or selected the plastry and they propagate in the large scale plantation, and then we use the spacing for the planting, and then how the impact for the wood properties. If you already choose the best clone for the high growth, it will be effect on the wood quality or not. This is the second question. And then for the Prof. Tani, and then you already mentioned about the molecular genetic to choose the best clone using the heritability, but based on the molecular genetic. How we can implement it in the operational plantation? Because sometimes after we already choose the maybe genes, the best gene for the growth, but how the application to choose which one the individual have the good gene for plantation, especially for clones. And then from the Prof. Sumura, that you already mentioned about the impact of climate change for teak, and we know that based on the eco study that our genetic diversity is still high diversity, especially for the old teak in Indonesia. And then how we can conserve the genetic diversity still exists for the teak, because some extent we already use the clonal plantation, we use the only narrow genetic base. Thank you.
Thank you very much for maybe 1, 2, 3, 4, 5 questions from Professor Widi. And the last questions from Professor Sri Rahayu, please.
Yeah. Okay, thank you. My question addressed to Professor Tani. According to the heritability, as we know that in Java, particularly the teak were planted with agroforestry and high input for the productivity. So it is high also possibility that many pests and diseases also involved in the plantation now, and many of where the ticks still in the nursery until young, they also impacted with many pests and diseases. So as you Pak Widi also mentioned that we only have unfortunately only have 2 clones. Yeah, is it so you know that there's very potential high effect from pests and diseases and also some mosquito and many. So how do you think if we want to increase the resistance to some maybe in the future many dangerous pests and diseases? So what do you think? Is it possible that only 2 clone, or maybe you have many suggestions about that? And also, and another thing, we also still have so many seed sources, from generative seed sources. So we need also your suggestion how we have to maintain our sustainability, take productivity according to our material genetic that you know that it is not easy because this is already in the long time, but we still have this material. Thank you.
Thank you very much for the questions from Professor Sri Rahayu. So we have 6 questions from the participants. So please for the speakers to answer the questions. The first, the question from Dr. Simon.
Okay, thank you, Dr. Simon. Yeah, you asked about the environment effect, yeah? Okay, yeah. Yeah, we have already tested all for at least for location represented the different sites, different microclimate also from West Java and then also Central Java and East Java. If we compare from West until East Java, we know that at least the precipitation in West Java has highest precipitation, and East Java has lowest precipitation. And then there are also the different types of soil, different types of fertility. So we have already planted at least at 8 sites, and then we also started with. Actually, we have already started from. From 600 plus trees, I have said that, but unfortunately from this 600 plus trees, we can only propagate around 25%, because not all of the plus trees can be what we call, for the rooting ability and sprouting ability is very low. And then we have known that the effect of the environment is there are also significant. There is also interaction between clone and with sites. So we have also know that the best clone, I mean the best 10 until the best. The best 10 clones from one side to other sides, there are variation. But we know there are 2 clones that Dr. Savitri said, we call it miracle clones, always have the best performance in almost every site. And then the Perhutani as the institution decided to propagate only these 2 clones. But we have already said that it is too risky for long-term adaptation. And then we propose them to increase the genetic base. So in this case, the environment is very important for actually for future anticipation. For if there is what we call climate change, and also mitigate for as Prof. Srira you said, if there is to mitigate the pest and disease, for example. And if Professor Widiatno said that, how about with these 2 clones? Actually, the Perhutani, I've known that there is also efforts to increase the number of the superior ticks, and they continue with testing of the next what we call plasteries, and they try to evaluate again and make a rank from the best clone, and then propagate. And now they make the next clonal test. So hopefully, not for a long time, they will also have at least more 4 clones. But I think this, for long term, I think the breeding should not be stopped. We should continue in order to increase the genetic variation, also increase the productivity together. The ideal, what we call the ideal method is if we can make jointly cooperation research between Indonesia, between Thailand, for example, and then with Laos and also India, that they have the natural distribution. This is the ideal situation, if it is possible. But for the short term, we should increase the method because from the 75% of the plastids cannot be propagated for mass propagation. So we have still homework how to propagate it, and then how to test again for the next generation. I think this is my conclusion. Thank you.
Thank you very much, Dr. Sapto. And the next answers is from Ms. Somporn. How the impact of the spacing or using your clones material on wood quality?
Okay. I will answer in an overview of all questions from Laos and Indonesia people. Okay. I would to show multiple breeding population program of Thailand slide. Okay. Slide number 7. Yes, slide number 7.
Slide 7.
Okay, thank you. Slide 7. Yes. Yes. We in Thailand, we should party from genetic resources. party we will research molecular genetic for teak breeding based population. Okay, party have many tastes, and party have corn bank. Corn bank is famous and important of improvement. In Thailand, have 500 level party in Clonal Bank for bud and shoes, and Clonal Bank can select to Clonal taste. Clonal taste in Thailand have 5 sets. 5 sets in Thailand. In 6 size, 5 sets. In the one set have success. It's difficult for research. 5 sets. In one set have success because we have heritability analyze value. Top 10 of party we have mating for full ship progeny test. Full ship progeny test, we have select top 10 for super teak. Yes, we propagate by root cutting and tissue culture propagation. Yes. In the future, we want to we want mass production product. Okay, thank you for answer.
Thank you very much, Ms. Somporn. And the next answer is from Professor Tani. How you can use the result of molecular genetic for the implementations? Yeah, thank you.
Thank you very much for your question, and also the attention for our presentation. So, in my study, I'm very interested in the very large variation of the hardwood and softwood proportion. This is a very good target to select the good chick in the future. So, but at the same time, in my opinion, we must understand the merit and the demerit of the clonal forestry. So actually, clonal forestry has a lot of merit because the clonal chick forest is very uniform. So this can produce very uniform timber to for example, industry of the teak furniture company and the sawmill company. So this is one of the requirements from the industry. That's why the plantation and also management of plantation and also the downstream, the sawmill and the furniture company, we can produce very good timber for the users. This is one of the merit of the clonal forestry. But at the same time, there is some demerits because the clonal forestry has no genetic variation. That's why the resilience to the environmental changes are not so high, very weak. If there is a high storm come, the clonal forest have sometimes highly damaged. This is one of the demerit of the clonal forestry. Another thing is there is no further improvement. If we have some mating, we can create another genetic diversity. This might have a higher, for example, growth and a higher hardwood proportion. So if we continue clonal forestry, there is no further improvement. This is another demerit of the clonal forestry. That's why we have to consider about the balance, clonal forestry and conservation of the genetic diversity. Conservation of genetic diversity is also very important for the further improvement of the teak. So in the near future, we have to think about the balance of the clonal forestry and conservation of the genetic diversity. This is my opinion. Thank you very much.
Okay, the next answer is from Sumra Sensei, how we can conserve the genetic diversity, especially in Indonesia. You mentioned before that our genetic diversity is lower than the natural populations. Please.
And in Indonesia, you use just 2 elite clone for the planting material in cheek. And then that's a clonal forestry. Then maybe that's genetic diversity very narrow in that case. Then Tanya already answered that question. But in Japan, we have a long history for the clonal forestry. We have a more than 400 years history for clonal forestry, Cryptomeria japonica. That's a Japanese cedar. But especially western part of Japan, and that historically those foresters select the good clone for the plantation, then continue to use these clone for the plantation. But number of clone much higher than in here. In the, for example, in the only Kyushu Island, they selected more than 23 clone. Then each area use only one single clone. But if you move the next mountain, they use a different clone. Therefore, in total, in the area, they have some genetic diversity within these area. This is important to avoid the risk for some accident. For example, global warming. Then in that case, it's increase some insect or disease. Therefore, to avoid such a risk, maybe it's you select more elite clone and just doing between the crossing between the elite clone. Then also each country, Thailand, Laos, and Myanmar also selected the elite cheek clone. Therefore, just imported this clone. Then try to plant to here. Then sometimes it's just crossing between the two clones. Then makes a new one. That means they increase the number of the elite clone. Therefore, at least that's my opinion. 30 clone, if you select for the plantation materials, that's enough to maintain the genetic diversity for the cheek plantation. This is my answer. Thank you very much.
Thank you very much for the answers. And the last question is from Professor Sri Rahayu, how to increase the resistance of our clones now, and also the relationship between the resistance of pests and disease with the heritability, because Professor Tani previously informed us about the genomic heritability on growth and wood quality. How about the resistance of pests and disease?
Okay, I'm sorry, I forgot to answer about the resistance. Actually, we didn't measure about the phenotype of the resistance, but that's why I can not answer to that particularly in cheek. But normally in the forest tree species, there is many studies to select the individuals to have a resistance against some disease and insect attack. So normally the genes related to the resistance, the number of this kind of genes is not so much. The smaller number of the genes regulates resistance in the normal, according to the previous study in the forest tree species. So sometimes the single gene regulates resistance. So that's why to identify which kind of genes regulate resistance, it's easier than the selection. For example, the selection for the phenotype controlled by a lot of genes like growth. So but problem is how we identify the genes. Once we can identify this kind of genes, it's easy to select the individuals that have a resistance. Yeah. So to identify the genes, we have good materials and also some previous study to identify. So for example, now we study about Sengon. So Sengon have this rust disease. So in Indonesia, you have a lot of the experience to do the inoculation of this rust. So this kind of the knowledge is very important to identify some genes control this resistance. And then once we can do this identification, it's very good information to select the new individuals to have a resistance. So the knowledge and also the technique about the inoculation, like inoculation, is very important. Okay.
Thank you very much, Professor Tani, for your questions, and thank you for all invited speakers that already answered the questions from the participants. And I open the next questions, maybe. Okay, Miss. Sorry, I forgot. Yes, please. Okay, Dr. Rama, please.
Okay. I'm Lerma Maldia from the UP Los Baños. Actually, Prof. Tsumura Sensei is also my supervisor in Tsukuba. Sensei, I just have one clarification. Actually, it's a more of confirmatory based on what I understood, and thank you for a very interesting presentation. So you mentioned that the Indonesian teak is genetically similar to Myanmar and Laos. And then you were able to identify a particular adaptive loci. So, and in the genetic structure, the Myanmar and Laos seem to have a different cluster. Did you have any analysis? Probably this cryptic genetic structure from Myanmar and Laos is attributable to having an adaptive locus to temperature, to precipitation. Because, and you also mentioned that because the genetic diversity from of the natural forest is, from the natural less genetic diversity of plantation versus the natural. So would you suggest that the infusion of genetic variation may be coming or should come from the Myanmar and Laos? Sorry, it's a long possible relationship based on the result of the adaptive loci. Sensei, can you attribute those adaptive loci to individuals coming from Myanmar and Laos? It's a very long. Sorry.
Actually, your question is a bit difficult to, and to detect such adaptive candidate loci for the adaptive genes, we use just eight natural population. But to detect such actual genes, probably we need some more natural population. Then 8 population is not so enough to detect the real adaptive gene. Then also this, we need to also the very detailed climate data.
Okay.
Then in India also we use a 3 population, and Laos, how many? I forgot. Laos are 3. The Thai and Myanmar just 1.
I see.
Therefore, we need a more population.
Okay.
Therefore, this is just candidate loci. Then mostly, I think 90% false positive. Therefore, in this analysis, it's not enough to do. Then we have to collect more population in the natural forest. Then we may detect some real adaptive genes from that. Then, so fortunately, the genome size of the cheek is very small. Then we can use the whole genome sequencing.
Okay.
Then already that published. Then if we get a large SNP data, of many SNP data, we can assign each SNP. Then we know the location of each. Then after that, we use as LD linkage disequilibrium, value of the linkage disequilibrium. Then we can find the real adaptive genes from the genome. Therefore, we need some more deep study. Then the result is a genetic structure in the Indonesian cheek, because more than 100 years ago, the number of introduced tree or number introduced seed is very limited. Therefore, this genetic diversity is very low. Therefore, that's result of structure also. Someone close the Myanmar or Thailand, but that also just limited materials, very small in that time. That therefore results just like that.
Okay.
Is that okay?
Thank you, Sensei.
Okay.
Actually, so that means that the history or the breeding for tick, molecular breeding for tick, especially for climate adaptation, will take more years maybe. But thank you. Very interesting results, Sensei.
Thank you very much, Ms. Lerma, for your questions and also answer from the speakers. Ladies and gentlemen, so we finally come to the end of these sessions, the first sessions. But before I close the session, I would like to take some conclusion from what the speakers has presented and from our discussions. So in these sessions, we got many important information and new insight from the speakers and also from our discussion. The first, the breeding programs in tick is already in advanced status actually. We do exploration from many provenance, from many countries. And then we conduct plaster selections, establish the provenance test, progeny test, and also we establish the clonal test. However, still we lack information about the genetic diversity and then genomic heritability in tick breeding. But we are lucky here because there are 2 speakers that gave us the new informations about especially about the genetic and genomic. Okay, and now we have reached the end of these presentations. So I would like to thank all speakers here, Dr. Sapto, Ms. Somporn, Professor Tani, and Professor Sumura, for the informative and interesting presentations. And also thanks to all the participants for the very active participations. And finally, let's give the big applause for the speakers and for you all. Thank you for your attentions and have a great day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for all the speakers and also the moderator, Dr. Sawitri Esud MSc. The speakers, please remain on the stage or in front of us because the organizing committee would like to present the token of appreciation to the speakers. And we invite Professor Dr. Insinyur Suryo Hardiwinoto as senior expert and lecturer on silviculture Department of Faculty of Forestry Universitas Gadjah Mada to present the token to the speakers. Dr. Sawitri, please in front of us to take the photos in one frame with the speakers. Okay, thank you very much.
Okay, ladies and gentlemen, before you leave this hall, we will announce some information that you need your attention. We invite all participants to enjoy the lunch at Veranda Resto in the first floor, south side of this meeting room.
And for those who will carry out Salat Zuhur, the prayer room is in the east side of this meeting room. And then the next parallel discussion will start at 1 p.m. So make sure that ladies and gentlemen have entered this meeting room again at 1 p.m. Thank you and enjoy your lunch. Good afternoon, ladies and gentlemen. Welcome back again in the garden meeting room. Now we are going to the second session. We would like to honorably invite to the stage our moderator. She is one of the lecturers on Silviculture Department of Faculty of Forestry Universitas Gadjah Mada, with research interest on tree physiology. With research interest on tree physiology and silviculture, she was passed her doctor and master program from Faculty of Forestry of Universitas Gadjah Mada in PMDSU program, the program for master's education, scholarship towards doctorate for excellent undergraduates. Please welcome Dr. Nesti Pratiwi Romadini S.Hud.
Thank you for MC for giving me the floor, and good afternoon everyone. Welcome back to the session 2. Today I will be your moderator in this section, and in this section we have 3 invited presenters with 3 entitled, and in this section we will focus on the topic about the forest reproductive material for large-scale teak plantation. And to give the overview of what we'll be discussing, we will cover the title from the invited. And please join me in welcoming Mrs. Benjarat Prompen, Master Degree of Forestry, Biological Science. And then Mr. Phong Kam So, Master Degree of Science, and Professor Dr. Widiatno. Please join me in the stage and here. Please have a seat, okay? We have space 1 for Widiatno here. Okay, in this section we will have some time question and comment in the end of the presentation. So for the participant, you can encourage to ask question or maybe share the experience and any relevant present research or projects, and then to be interactive discussion, don't hesitate to give a question in the end of the presentation, and I will give allocated time to Q&A session. And let's start the discussion today. And now I will introduce our first speakers, Mrs. Benjarat Prompen, Master Degree of Forest Biological Science from Forestry Technical Officer, Royal Forest Department, and Forest Research Development, who will give an incredible lecture titled about the seed management and propagation of teak of Royal Forest Department, Thailand. And she is also Chief of Forestry Improvement Research and Forestry Seed Management Section, Silviculture Research Division, and Forest Research Development Officer. She is also head of Northern Forestry Seed Center in Konkan Province, Silviculture Research Division in Royal Forest Department. On the other hand, she also doing an ongoing research project entitled Biotechnology Application for Royal Forest Development, Elite Siamese Rosewood Conservation, and also enhancing potential of Royal Forest Department Teak improvement clones by biotechnology. To Mrs. Binjarat, you have 20 minutes to present your presentation, and now time is yours. Saya meng-highlight tiknya, Pak. Kayak kalau dilihat itu nggak ada tiknya. Yang mana tiknya?
Okay, thank you for introducing me. Good afternoon, ladies and gentlemen. I am Benjalat Prompen. I am really pleased to join in this seminar. First of all, I would like to thank the seminar committee to invite us, our team, to join in this seminar. We are from Royal Forest Department, Thailand. As a speaker, today I would like to share some of our works on the topic of teak seed management and propagation of Royal Forest Department, Thailand. Okay, in the morning, Ms. Somporn present in this morning about teak improvement of Royal Forest Department. You can see that we have a lot of good material, good genetic material of teak for seed collection and propagation. For the genetic conservation, it's essential to be a good seed bank. If there are a low genetic diversity when a leaf arrives, extinction will occur. Teak distribution in Thailand normally occur in natural forest in Thailand. In protected area, it about 59%, and outside protected area is about 41%. Almost distribution occur in north part of Thailand. At this slide, the geographical grouping of teak population in Thailand based on the result of the DNA structure analysis identified 6 regions and 1 admixture zone. As you can see, so we have, as Ms. Somporn presented, now we have 2 types of seed orchard. We also have Clonal seed orchard, CSO, and seedling seed orchard, SSO. The objective is to produce high genetic quality seed for plantation and to serve as a breeding orchard for conducting controlled pollination. So we have 636 plus tea selected from natural and plantation all around Thailand. This is a teak putty, the picture of teak putty selection from highland in Mae Hong Son province. The elevation about 1,200 meters mean sea level in Mae Hong Son province, north of Thailand. Could you please show? Okay, thank you. Now we have 12 sites of teak ex situ plantation around Thailand. For the Clonal seed orchard in Thailand and seed productivity, as you can see in this slide, Mega Civic Cultural Research Station produce about 950 kilograms of seeds per year. Uh, sorry again. Okay, this is a picture of our seed orchard. So we have seed orchards. It's about 784 hectares, and seed production area is about 225 hectares. The left side is our Clonal Teak Plantation, and the left side is progeny trade. And in around August to October, the teak start to produce young fruit. And we can collect the teak dye fruit in January to February in each year of Thailand. This is an example of collecting seed from the plastic. And after we collect from the plastic, we run extraction of the teak dye fruit and cleaning. And we cleaning and sorting and weighting. So we run a seed laboratory. For example, we measure the size of the dye fruit. Okay, this is our work. And for the teak dye fruit, it looks like they have a dormancy. So we try to check that in one dry fruit still have how many seeds inside. So normally we get four seeds inside, but almost of our observation, we found the teak about 54% that have only one seed, and 21% have two seeds. This slide shows the storage. We store dry fruit in the room temperature with airy and breezy. And now in our department, we have tea seed bank in Thailand. We have in the Lampang province, north of Thailand, northeastern of Thailand in Khon Kaen province, and the central is the Royal Forest Department in Bangkok. Now we have total teak seed is about 7,327 kilograms. So total teak seed collection during good seed year, we can collect teak seed about 4.5 kilograms per patti. But in poor seed year, we can collect teak seed about 1.2 kilograms per patti. And after we collect it, we run the germinal test like this. For the germination test, the teak seed is often poor due to dormancy, and therefore it requires pre-treatment by alternate wetting and drying for about 5 to 7 days to break the dormancy. So we do like this, soak in the water, and after that dry in the sunlight for 7 days. After that, we sowing seed in the seed bed. We compare each year of seed storage, and different type of germinate material with full replication. And after 2 weeks, seeds start to germinate. Okay, we still collect the data about growth of the seedling continuously. For propagation of teak, at the first I will present about seed propagation, how to do. We make a seed bed like this, and after that pre-treatment, and then sowing in the seed bed. And this is a seedling from seed propagation. We take care of our seedling in every day, watering about 2 times per day. And we got the seedling like this. And for the alternative propagation of teak, we run vegetative propagation, for example, budding, cutting, tissue culture. This alternative technique, we can get the seedling same quality as the mother tree. We can run the mass propagation and use short periods of time. And we know that for vegetative propagation, we can get the strength growth and maintain uniformity. And side branch will be less, which will not affect the volume and quantity of the wood. All plant will be equal, which keep expected yield and more resistant power to pest and disease. All of the genetic material we got from our tree improvement program that Ms. Somporn presented earlier. And this we run the budding system. And we run tissue culture too. This is we test about root initiation of teak. Now our department have got the best media for tissue culture of teak and best media for root initiation, so we can run the mass propagation now. And after that, we transplanting of tissue culture pellet to nursery for acclimatization. And the challenge and future work on seed management and propagation, we will improve capacity of SSO and CSO by thinning for increased seed production and fertilizing the plastic. And after that, link with the breeding program. Now we have collaboration with the CHERCAS to learn about molecular breeding. And for biotechnology, we will try to set the tissue culture in case of use bioreactor for mass propagation. And alongside with that, we updating long-term breeding strategy. And finally, we will get mass propagation for distribute to the Thai farmer. For example, seedling propagation, vegetative propagation, and we try to collaboration with the potential organization, for example, overseas country, university, and community to join our work. And this for future work on CSOT, Clonal Teak Plantation of Royal Forest D. Now we have five sets of Clonal Teak. We will run this and try to improve and find out the best cone for propagation and distribution to the all around Thailand. Thank you for your attention.
Thank you for Mrs. Benjarat for your presentation, and we learned about how in Thailand's teak improvement programs from the seed cutting and tissue culture. So we move to the next presenter, and it's time to our second speakers. Please, Mr. Phongphilay Phonghamso from the Director of Administration and Planning Division and Director of Administration Planning Division in Lao PDR will be give a lecture about the teak seed source management and seed supply in Lao PDR. So he also contribute in the teak research and read some books, and also being expert in the afforestation and reforestation. So it's time yours. You have 20 minutes to present your materials.
Thank you for introduction me. First of all, I would like to thank UGM Faculty of Forestry, Indonesia, for inviting me to join this international meeting today. I also thank you to the JCAS for supporting to bring me to here. Dear own participant, I would like to share with you on the teak seed source management and seed supply in Laos. Just highlight the country profiles. Agriculture and forestry play important roles in Laos. PDRs is a number of workforce still mainly in the agriculture and forestry sector in Laos. Forestry still play important role for the Laos, particularly in remote area. That's rely on non-forest resources for subsistence, especially for non-timber forest product. As you see, the map is Laos is connecting different countries. It's on the North China, and then we have Myanmar and Thailand. Also in the south is Cambodia. In terms of forestry in Laos, in the percentage, still okay compared to ASEAN country, but in terms of area, still small. Currently, we have 62% based on assessment in 2019. The government have policy to set up to increase forest cover to 70% by 2025. So in addition to support the forest cover, there are a number of national policy related to forestry. Among these important is law of forestry, law on the land, and the number of decrees is also promoted, particularly on industry, plantation, and environment protection. In addition, there is also a number of forestry strategy has supported, particularly on the forestry strategies up to 2035, national clean growth strategies, and others. In order to support this number of policies, tree plantation is very important. So tree seed source is play important role in terms of support the government policy. So in 2002, Laos Forestry Research Center, FRC, established tree seed source. There were 102 seed source. This project was supported by Danish government, which consists of 6,500 mother tree or pasture tree, representing 6,000 or representing 29 different species. And then this seed source were officially endorsed and managed by Ministry of Agriculture and Forestry in 2006. Among these Laos tree seed projects, which are funded by DANIDA from 2000 to 2003, was established there was 102 seed source. Based on currently assessment, there will remain 76 seed source across the country. Among these, 9 teak seed source. There's there. In 2019, natural teak resource was supported by ITTO TICS project to encourage and conservation of genetic resources, particularly natural teak resources, has been supported. Among 9 teak resources in Laos, there are 5 resources in the north, particularly in Luang Prabang and Sayaburi, and then 4 resources in the southern part, particularly in Salawan, Sekong, and Champasak. As shown in the map, you see here that we have assessment. As I mentioned, this highlight one. Laos is one of the countries that have natural teak resource. Is from India, Myanmar, Thailand, and the last small park is in Laos, in Sayaburi province. It's close to the Thailand. This among there is around 10,000 hectares with mixed forest this year. In addition, our effort is try to conserve the teak resources. Particularly, we got supported from different projects. Particularly, we have established 2 resources in the Upland Agriculture Research Center in Luang Prabang. This number of the +3 or has been introduced to planted in station, particularly in the Luang Prabang. It's supported by Asia projects and the Lao Australian Teak Agroforestry Research Project. Here the other one, just not only the conserve the genetic resources of the teak, the study on the different space planting also has introduced to test it in Luang Prabang province. This they call Neo the Well experiment. The idea is to see the different spacing of plantation, of tree plantings as well. We want to plant mix with other crops. As I mentioned in the north, there's some effort to try to conserve in the southern part of Laos, which has own tree plantation, which planted in 1943, as I remember. And we also has set up the other one as a selected mother tree or plus tree. The objective of this project is try to conserve the material. We work with particular in the provincial forestry office. Particularly, we define borders among these seed source. We also have conducted the elite planting and enhance our participation in the villages to join on the in terms of management, as well as this means our regulation on the seed source, in order to get the farmer and the local people understanding the importance for their generation. In addition, we also have established seed orchard in Forestry Research Center, which we also collected from provenance, 7 provenances, is supported by ITO TICS projects. In addition to this, we also try to build the capacity for the farmers who are interested in this project, particularly on the silviculture projects. We also support this in this Luang Prabang and Sayaburi province. This one include training on the silviculture technique, which include pruning, thinning, as well as volume assessment. as well as others one. This is material, it's a training material that we develop it in Lao language. In terms of sea salt management, there are a number of challenges that we face, particularly land encroachment in natural thick forests, particularly for agriculture, infrastructures, is quite a challenge to Laos in terms of conservation of these for the future management. Other one's issue is on the how to protect the mother trees. It's quite because it's located quite far away. In terms of market, the seed we still is really weak in terms of this in connection with the buyer on the seed. So there's a need to a lot of improve in this area. The other challenge is on the as I mentioned in the number 1 and number 4 is the changing, always keep changing this challenge in terms of land use or this area. The other one is on the forest fire as well. So here is some number of recommendations that we, particularly how to protect plus tree or mother tree. So we try to develop the different project proposal to the different donor as well as government of Laos in order to conserve these sea source, particularly on the number of activity as mentioned here, where we could propose in this activity, which include set up mobile station, train and equip local communities to be involved in this protecting. The other issue is in terms of marketing. So we try to work with local community and organize to establish seed network. And be partnership with different nursery or organization that can help propagate and distribute the seed. As well as capacity building to local community in terms of seed handling. The other ones is develop or implement priorities to protect this seed source. Number of policies, be involved with different stakeholders as well as in order to get understanding the importance of the mother tree to conserve. So number 4, so for us 5, yes, of course there are a number of activities to assist the farmers to be in hand with this. And the last one, how to enforce the existing law and regulation to work with this in order to conserve our tree seed source. This is some thoughts that I could share with the meeting today. Thank you very much.
Thank you very much, Mr. Phong Phuay, for your presentation. And we already studied about the seed management in Laos and Thailand, but we will also learn about the seed management in Indonesia. And we move to the third speakers. We have our professor from Faculty of Forestry. He is a Professor Dr. Widiatno, who have expertise in the intensive silviculture and also reforestation advisor in the Indonesia, and also rehabilitation in the peatland and restoration. So he also have some publication about the teak, and today's Mr. Professor Widyatno will present about the mass vegetative propagation of teak for forest rehabilitation in Java monsoon forest Indonesia. So you have 20 minutes for your presentation, and time is yours.
Good afternoon, everyone. Today I will present about the mass vegetative propagation of the teak forest rehabilitation in Java monsoon forest Indonesia. Okay, first of all, I will say that the teak is one of the most valuable tropical hardwood species in the global markets, and then we know that the teak is actually not native species of Indonesia. The natural distribution of the teak is mainly in the Myanmar, India, Thailand, and Laos. However, the teak log from the natural forests are declined due to overcutting, deforestation, and probably other land use change. So the forest plantation is one of the good opportunity to produce the wood of the teak and also sustainable forest, and also sustainable for supply teak wood in the global markets. And in Indonesia, the teak plantation is maybe in the number of the forest for the teak plantation is more than 1 million hectares, or 60% of the Java production forest in Indonesia. And then, I just remind some of the roadmap of the teak improvement program already, I think already stated by the Dr. Sabto in the morning, that actually the started collecting of the mother trees is started in the 1979, and then Prof. Naim, Pak Sabto, and others colleagues already collecting more than 600 plus trees in some area in Java. And also after that we established some progeny tests, and also established of the silviculture trials. After that we already selected more than 150 clones based on the growth and the rooting ability. After that, after we already select the many clones, we established the clonal teaks, and then we choose the best clone, 2 clones for the large-scale plantation in Java Island. Another hand, we know that the people in Java is more than 50% population of Indonesia live in Java. Just why the plantation in Java, especially for teak, combined with the social aspect with the crop plantation under the teak to produce the food for the local peoples. And the future, we try to increase still the productivity, and also how the GWAS analysis and also adaptation of the teak can be established, and how they can survive in the Java for a long time in the future. And then I think in the mornings, our speaker, Dr. Sabto, and then Dr. Sampon, and then Professor Naokitani and Professor Sumura already discussed about the opportunity of the progeny tests using established by the progeny tests as a molecular to choose the best clone to select for the rehabilitation and plantation. And then first of all, after we select the best clone for the teak plantation, after that we establish like the head orchards, and then after we already established the head orchard, we produce the seedling for vegetative propagation to support the large-scale clonal plantation. So the mass vegetative propagation of the teak we have the many steps. First, establish the head orchard, and then large-scale seedling production by the shoot cutting in the nursery, and then preparing and the maintenance seedling for clonal teak plantation. Yeah, this is just illustration why we want to use the clone for the plantation, because we compare the growth of the teak from the seed production area, mainly generative propagation, and then shoot cutting, and then in this data we can see that after 15 years, especially for the teak planted by the seed production area, they have the average DPH is 30 centimeter. But when we use the select this clone, after 5 years, the DPH almost similar, 30 years, 30 centimeter, and with the low coefficient variation. It means when we use the best clone, I think we have the similar growth from the many individual in the plantation. Okay, and then how the strategy for rejuvenation of the teak clone to produce the seedling or vegetative propagation in the forest nursery. I think some method we can compare to produce the seedling. First of all, I think we can use the tissue cultures, but tissue culture probably we need the main equipment, and probably for the large seedling production, they need the more cost. That's why for the teak, I think macro propagation is also suitable. First of all, we can use choose the best individual. After that, we propagate by the budding. It means after that we prepare the what I call it stem, and put the budding from the good clone. After that, we maintain, become a seedling, and establish the head orchards. And this head orchard we can use to prepare the shoot cutting for the large-scale seedling plantation in the nursery. I think this is the best method and the cheap method for production the seedling in many individuals. Actually, for budding also we can direct from best clone, and then with budding and direct the planting in the plantation. And we compare on the growth of the budding and also shoot cutting in the 2020 from the Ardiansa. We say that no significant difference between budding and then shoot cutting. It means two method vegetative propagation we have similar growth. But one of the consideration when we choose which one the method, the best method for the propagation is how the easy way and also cost. I think the shoot cutting is easier and also cheaper than budding, because for the budding, first of all, we need the additional additional cost to prepare the stem of the teak, the seedling with the large diameter. After that, we put some budding in this stem. So this is the more additional cost. But for the growth, I think between shoot cutting and the budding, they have no significant difference. That's why for the large-scale plantation, we use the shoot cutting for propagation and plantation. And then how we can prepare the seedling in the nursery. First, we must find the good media and the hormone. We use the coco peat combined with the coco peat, and also we compare coco peat and the soil, and the result that from the coco peat they can produce the higher rooting ability compared to the soil, and also the best EBA hormone is 150 ppm. And even last time when we already select the many individuals, they have the different rooting ability. And then how we can application for the large-scale plantation, because we see that our system is the silviculture system, when the silviculture component is in the three type: regeneration, tending and harvesting. For the large-scale plantation, from the clonal, I think one of the important thing is the tending, it means thinning, because even the teak is one of the high growth, but if we didn't give the good space, they will, and the growth is become lower. This is an example. Example from the comparison between the clonal, between thinning and unthinning method. The Clonal Teak Plantation established in the 2002, the spacing 3 times 3 meter, and the average DBH after 20 years planting, unthinning method, even this clone is similar, but if the plantation didn't do thinning, the average of diameter is only 23.8 centimeter in the 20 years. But if we cut and what I call the thinning, and then remain the individuals around the 150 until 200 individual per hectare, after 20 years, the DPH become 44 centimeter. This is one of the advantage of the management of thinning. One of the maintenance on tending for the forest plantation. So just why we already choose the best clone for the planting, I think we need some silviculture technique to improve the growth and then to get the optimal harvest in the final cutting. And then another hands development agriculture plantation. Actually, some of the plantation in Java, mainly we use the Tongya system or agroforestry, because we know that more than 50% population in Indonesia stay in Java, and then they need land for agriculture crop. And then some of the method will be developed, and I think tomorrow Prof. Budadi will explain more how the agriculture plantation, agriculture of the teak can be contribute for the food security for local peoples. Yeah, and then we also already measure about the impact of the thinning intensity for the cutting, and also impact on DBH, and also for the volume. We can see that actually if we already cut the tree, and then with 50% of thinning intensity, the DPH become larger, but the volume become lower because we reduce the number of individual. But we must know that for the teak, I think not only volume we want to get in the final cutting, but also the large diameter, because the price of the teak is depend on the size of diameter. And then if the diameter is larger, even the similar volume, the price become higher. And then we analyze that even we already cutting 50% and the volume in the final harvest is become lower, but for the income is higher compared to unthinning. And then another hand, we also try to measure the carbon sequestration. Even the teak is also for the wood production, but the teak have the long life, and we try to measure the carbon concentration. Actually, if we didn't do the thinning, in the 20 years, we can get around the 205 ton carbon equivalent per hectare. But if the thinning, in 20 years after planting, we can get 126. But actually, this plantation already harvested in the 12 years after planting, and I think this is also product of the carbon. So for our research and our experience, we know that the clonal plantation have play key role for the increased forest productivity and carbon sequestration. And also it is very important for us to rehabilitate, especially in the monsoon forest with the teak, because we already select the best clone. Even we only use the very narrow base genetic diversity, and maybe in the future we can collaboration to increase and also to maintain the genetic diversity still exists in the teak, especially in Indonesia. So the productivity will be increased every time rotation. Thank you.
Thank you very much, Professor Widi, for very insightful presentation. And for all the speakers, now we have a Q&A session. So for all participants, don't hesitate to raise your hand if you have some question or comments or others sharing experience that to us to all presenters. Maybe in the first session, I will open 3 questions first. Anyone? Okay. Please, microphone raise to the participants. Please state your name and your affiliation.
Okay, thank you very much for the opportunity for me to raise a question. I interested in the topic from Dr. Pinjarat Prompen. I want to ask you about the sprouting ability, and the rooting ability of the plus trees if we want to propagate vegetatively. Because as I said before in my presentation, we have tried from 100% of plus trees, we can only propagate only 25%. How about your experience? You said that you have already propagated using seeds and also using vegetative propagation. And then the second is for Professor Widiat. No? As we heard this morning from Dr. Bambang, the Director General, you said that there are so many people in Gunung Kidul area are still using unimproved seed. Also, we know that unimproved seed resulted in variation of growth, and therefore variation also the productivity. Of course, lower productivity in comparison with superior clones. So we have learned that many people have already also started to use superior clones. What's your comment? How to deploy? Because Dr. Bambang also asked us how to deploy the superior ticks in order to meet the need of the people, because they actually want the best clone, and they want to also increase the productivity of the forest. Thank you.
Thank you very much. Next question from Dr. Savitri.
Thank you very much. I would like to ask to Ms. Prompen. I have 2 questions. The first question is related with your speech before, that you mentioned there are 2 techniques to propagate the tick. One is generatively using seed, and the others is vegetatively using budding, cutting, and tissue culture. I would like to ask which one is the mostly used in your country, and which one is the most effective. And the second, this is about the plantation in Thailand. How about the comparison of teak plantation established from clonal seed, and the others is from maybe other clones? So comparison, the teak plantation as established from clones and from seed.
Pardon,
Thank
Dr.
you.
Savitri, could you second questions about the...
Yeah, I would like to know the comparison, the area that established from clones, teak clones, and from seed. Thank you.
Okay, maybe others participant. Okay, please, your name and your affiliation.
Benjarat, actually basic biology on the seed germination. You said that there are, for the 4 seeds per fruit, 54% and 21% for 2 seeds. But among those 4 seeded fruit, thick fruits, did you estimate the viability or the germination out of the 4 seeds? How much germination, and in terms of the viability, does it have effect on the number of seeds between 4 and 2 seeded fruit teak?
Okay, thank you. I think it's enough for this session. Maybe first for Mrs. Benjarat, from the question from all the participants, maybe it's effective to answer. First from the Dr. Sabto, and already get the question. Okay, and then from the Dr. Savitri, and the last one about the estimate of germination ability.
Okay, thank you for your question. First, I would like to answer about the propagation. I will include the question from both of you. It's quite similar to each other. About propagation, normally in Thailand we use seedling propagation because it's easy to produce. And for the clonal seed, for the vegetative propagation, we also succeed in budding and cutting. But for tissue culture, now our laboratory have only two lab in Thailand. So it's quite cannot run the full stream of our ability. So and the tissue culture is quite take a high cost to run, but budding and cutting is take a low cost to produce. So and for budding and cutting, our department staff can do it, and we setting the training program to teach the farmer to do about cutting and budding. So it's quite easy to do. It's okay. It's about this first question. Yeah. Okay, and for tissue culture, as I present, now we have got the budget to run a research on tissue culture. We try to invent the new technology. For example, we will use the temporary immersion system, bioreactor system, to produce seedling from culture, tissue culture. That we expected that we will get the high amount of the seedling better than the solid agar wood. That's normally we used to do. Because bioreactor, we will use like a liquid media to propagate the seedling in the laboratory. And the second question about clonal seed. I would like to show the slide of the total area. You ask about total area, like?
Which one is bigger? The plantation established from clones,
Mm-hmm.
or from seed? Which one is wider?
Wait a minute. Which one? I forget the number. Sorry. Now we have seed orchard and seed production area from seedling seed orchard higher than the clonal seed orchard. Okay. And for the next question about seed proportion, right? At first, we test about the seed viability first. We got that when we do a cross section, we found about 20% that we have zero seed inside the dry fruit. So that means we got the 80% of seed available viability. So after that, we test the seed that we collect in this year, 2023. We test the germination test. We got 90% germination at the slide I already showed you. Okay, thank you very much.
Thank you for the questioning, the answer. The next question from the Dr. Sabto to Dr. Widiatno. How to develop some progress thing to people, especially in the Gunung Kidul?
Yeah, thank you, Dr. Sabto, for the questions. Yeah, I think when we discuss about the clone, especially for special clone of the teak, sometimes the other discussion about the property right, because we know that to produce the selected clone, we need the long time and also huge budget and also sometimes long process. And then we know that probably last time Prof. Sabto and team collected in the 1997, and then maybe in the 2005 until 10 just developed the best clone. And then one of the challenges for deploying the special clone for the community forest is about the property right. And then, but on the other hand, we know that the community forest, especially in Java, is very huge number. For example, in the Yogyakarta, the state forest only around 30 until 15,000 hectares, but the community forest more than 70,000 hectares. This is the huge number compared to the state forest. It means the community need the special clone so they can get the high productivity, because when they use the unimproved teak, the production become lower. And then by the sprouting, Pak Bambang said that maybe the production less than 20 cubic meter per hectare. I think this is the lowest. So how we can give the access for the local people? I think government should be prepare the new method for collaboration probably between the researcher and also some company. They can provide the budget for example, CSR, and then establish in the progenitors of the tick. After that, after we already select the best clone of the tick, we can deploy for the local people by the free. I think this is the concern, because sometimes when the clone already already owned, when one of the company become the property right, is the complaint from the market like this. And then I think for the next step, we need to discuss more with the government. So after that, we can establish some production seed orchard or the head orchard for the short cutting, and then community forest or local people can get the free access to get this material. After that, I think we need like the empowering for the local people, especially how to produce the seedling by the short cutting, and then so every local people can produce by themselves without without they need to pay to buy in the market, because we know that the price is very, for example, when we produce the clonal teak, I think the price is less around the 1,000 rupiah, compared to the price in the market more than 10,000 rupiah. It's 10 times. And then if we can produce the high clone, and then local people can get the free access, after that I think we can support the rehabilitation in the local farmer, and also maybe, like last time we have the tagline, seed for people. Probably next time, clone for people. This is most important to support the increasing productivity in the community forest. Thank you.
Thank you very much for the two speakers answering the question. And I open to second session Q&A time. And anyone have a question? Okay, please, Dr. Yeni.
Thank you very much for your time. My question will be addressed to Dr. Benjaran Prompan. Welcome to Indonesia, by the way. I do conduct same research on the flowering phenology of a teak, and I found out that even the same genotypes, when it's planted in different sites, it will flowers differently. So in the warmer and more dry sites, it's flower earlier and shorter period. But in the wetter conditions, for example, with a higher rainfall, it flowers later with also longer period. And we also have the problem with the asynchrony flowering. I mean, among the best genotypes, we want to make them outcross each others, but it's more difficult because they flower in the different time. So my question is, how do you also overcome the same problem in your country or not? And the second question is, how to make they flower more synchronous? Thank you very much.
Already get the question? Not yet? Oh, maybe a short the question, please. Shorten question.
Okay. Yeah. Do you also have a problem with when they flower in a different time? So yeah, flowering asynchrony means if the trees flowers in a different time. Do you have the same problem? And if so, how you overcome this problem? Thank you.
She talked about the problems in flowering of the seed and how to handle it.
I will try my best to answer your question. In Thailand, I think the weather is quite different from Indonesia because Indonesia like monsoon region. They have amount of rainfall higher than Thailand. So in this case, now in Thailand, not much change about the seasoning of the flowering, fruiting. So it's quite not the same as Indonesia, the same problem. But I found that the effect of the climate change are still quite affect to our teak seed, because I found that I made sure the size, we made sure the size of the seed, the dried fruit. I found that in every year, in nowadays, the seed quite smaller than in the past. So but the season is quite the same time, but the size of the seed is quite different. And for actually in this year and last year, the seed is smaller, but it still can germinate like fast germinate than the big fruit. I don't know why, so I try to set the research to do on focus on this area in the next year. Thank you very much. Okay, I will give more information about this. At the Ms. Sompon present about, we set the plantation about seedling seed orchard, Clonal seed orchard. So at the first we try to set the high amount of the plastic to plant in the plantation. So at the very first the very first of my presentation, that we try to set the genetic variation, have a lot of plastic to plant it in the site. So in this case, we try to avoid about inbreeding of the same tree, same variety. So that is I think that the prevent about this case. Thank you very much.
Okay, thank you. Maybe I will give a suggestion. We must consider how many trees are flowers, because there may be a relation between the number of trees flowers and the quality of seeds. Okay, thank you. But that's very interesting. Thank you.
Thank you very much for the very interesting discussion about the flowering of the teaks between Thailand and Indonesia. So maybe one question more from the participants. Okay, if not, I have one question to Mr. Phong Philei before your speech about the holistic approach that involve the active participant and engagement the local community. And my question is, how about the access from of the local community to the seed from the seed orchard? There's a very close or there are open access from the local community.
Okay, thank you for the question. In Laos, generally, community can access to the seed collection. Usually, we provide training for the district official. We have provincial and district, local community, how to collect the seed or something, and then we try to promote them to in order to involve in this seed collection. That's why actually they could access to the seed in order to how to get the good material on this one.
There's no certification to make a close access from the local community to the seeds numbers.
In terms of certification, they still need to develop in Laos. We just the simple in terms of seed germination percentage or something. It's good or not? This still take the time compared to neighbor country. Yeah.
Okay, I think this good for the local people to develop their own in the land and not only in the government or research only. So I think there's in the end of the sessions. Before I close, I will brief presentation today's. We'll talk about the seed management in Laos, in the Thailand, and also how to make a mass propagation from the Indonesian seed resource. So before we close, we will continue the session after the coffee breaks, but maybe we have some photo session, and I will give time to Master of Ceremony.
Thank you very much, Dr. Nesti. Please big applause for the experts and also for the moderator.
And we remain on the stage, Professor Widiatno, Dr. Benjarat Prompen, and Dr. Phong Philei Phong Ham Sao. Sorry if I wrong in the spelling. The organizing committee would like to present token of appreciation, and we re-invited the chair of organizing committee, Dr. Insinyur Sabto Indrioko, Esud MP IPU, to present the token.
Thank you, Pak Sabto. We invite Dr. Nesti to take the photo in one frame. Okay, thank you. Now, ladies and gentlemen, we are going to the coffee break time. We will continue to the next session at 3 p.m. Please enjoy the coffee or tea and also the snack that has been prepared and served on the corner of this room. Thank you.
Thank you.
There are Mr. Simon Fong Kam Ho and Mr. Natalas Anis Harjanto. Please welcoming and join me in the stage, and please have your seat here. Thank you for your welcoming, and we will start the discussion. And first, we have our speakers, Mr. Simon Fong Ham Ho from the Forest Research Center, National Agriculture and Forest Research Institute, and Mr. Simons also have expertise and experience in the high value forestry in upland area of Laos. Some others expertise is about the growth characteristic of Tectonogenes related to soil and site properties in the mountains area and the Lao PDRs, and others project with a GCAS cooperation. And he is also have a publication about the relationship between the topographic condition on the teak root performed in the mountain landscape of Lao PDR. And we have some times from before session. You have 20 minutes for the deliver your materials, and please applause for the Mr. Simon.
Okay, good afternoon, everyone. I'm Simon Mongkamhong, working in the Forestry Research Center, National Agriculture and Forestry Research Institute. So today is great honor for me to be here to present you about our research collaboration with GCAS for a long time ago, in 2016. So today I would like talking about accessing the Atlantic thick pro and yen models in the mountainous areas, landscape of Lao PDRs. Okay, so as you may know, the TIC is the plays significant role for our economic developments. One of the species has flash growth in the mixed deciduous forest. As you know, the teak is the native species in the Asia. Laos is one country included among the native distribution areas, particularly in northwestern of Laos. So, ticks had been planted in large diversity of site collision inside and outside native area across the 70 tropical countries for many centuries. In case of our countries, Lao PDR, we have been planted since 1942. So, due to have the political problems, so the expansion of this species is not go smoothly. So until 1990s, the government has a strong promote to grow this species. Right now is the teak plantation area increased to 40,000 hectares. So you may see in the picture, is the planted area in the southern part of Laos. in Salawan province. Is measures the planted ticks, have more than 79 years old. So, as you may know, the tick growth and development is controlled by various factors. So, in general, the soil-site corrosion are significant factor influence the tick growth and development. For example, tick grow well in the rich calcium content and moist area, and especially in the bottom of valleys. So you may see in the pictures that taken by Dr. Imaya, is my colleague from the Jakarta. We have collaborative project to take the picture in the tick seed source located in the kilometer 10 in the Luang Prabang province. This plantation is planted in the 1962. Yeah, is bottom side is grow is the large side of the tick tree. So high quality timber teak is includes the tree quality, tree growth, and hardwood qualities. So the factors influence to have the high quality of teak is may have from genetics, silviculture management, and environmental factor. So in our research, we will not include, we will exclude the genetics because in our northern target province, the Luang Prabang, during we teak has the rapid expansion in 1990s. The genetics origin we are not uncertain from the east origins. So the purpose of our study is to accessing the growth and yield model of teak through analyze the influence of topographic collision on teak growth and yield models in the mountainous landscape of northern part of Laos. So our research site is located in the Luang Prabang province. Is the research site area is cover is two main districts in the Luang Prabang city and Siangan district. So you may see in the map we have draw the we say transit lines about the 31 kilometer. So we have selected the 61 individual plantation with the elevation is ranking from the over the 200 to over the 100 meter above sea level. So to overcome our objectives, we have to create temporary simple plot. So the plot size is the 20 by 20 meter, or equals the 400 square meter. So after we create the temporary simple plots, we have the field 183 the dominant trees. So for the purpose of the stem analysis, so we have the cut this for take a list to correct the sample. There are more than 2,800 sample lists. For after we make in the film, we store in the plastic bag to prevent the moisture loss. And after this, we bring the sample to our laboratory and use the sanding machine to the police. And after this, we scan the to be digital photo files with a high resolution of the 1,200 dpi's. After that, we have the calculate the tree rings using our developed measures software. We accessing the tree growth curves using the metric growth function. Y is mean the DPS or high is the egg growth. A is mean the upper limit growth, and K is the growth speed, and T0 is mean the initial growth. So in our study, we use the Spearman partial correlation using the R package to investigate the effect of side characteristic after remove the effect of stand characteristic. And we also use the partial rank correlation network RealCam. So this one is the circle means variables, and color of the circle means the types of variable, and colors and y of line between the two variables means the positive and negative. So please allow me to tell you about the key finding of our study. DPS the egg growth curves. The result of Spearman partial rank correlation analysis indicate that the DPS egg growth curve parameters initial growth has significant positive with elevation, while the slope position is versus the negatives. For subsequent growth speeds has significant positive with slope form, and upper limits grow, so significant correlation with the negative with the slope position. And the second one is the tree high egg and growth curve. The result of Spearman partial rank correlation analysis indicate that tree high egg growth curve parameter initial growth has significant positive with the slope and gradient, and growth speed so significant negative with slope gradient, elevation, while slope form was positive. And upper limit and limit growth so significant negative with slope gradient and slope position. Discussion. So our results, the tree growth has the correlation with the lower slope position, concave slope, and gentle slope. That means that the recent finding of our optimized site correlation for tree growth in GN's model can be supported for high quality because of there is no relationship with the site elevation. And please allow me to summarize the result of Spearman partial rank correlation analysis suggests that teak timber has the best quality with a high productivity as lower middle gentle slope interact with the straight concave slope at high elevation in this area. That means our research site is ranked from above 1,000 meters above sea level. That means the window of elevation is the support grow well. So the result of present studies provides scientific evidence critical contribute for developing long-term teak plantation management strategy to improve the timber production economic potential for smallholder in Laos, particularly in the mountainous area. Our research, I would like to thank the JIRCAS, Dr. Imaya and team to have the technical support and panel support, and also my university during I have my PhD research in Nagoya. Thank you for the support, and also local officer to help me to cut and carry my sample of the 183 trees. It's quite hard work. And also thank you for my director to support and encourage me to finish my research and my study. Thank you very much. Yeah.
Thank you, Mr. Simon, for your explanation about the assessing plant growth and yield models of mountain landscape in Laos. It's very interesting and there are good results. So continue to our second presenters. We have presenter from Mr. Natalas Anis Harjanto, Master Degree of Science. He is a Director of Operation of Perhutani, who will give an speech or talk about the excellent topic of experience in managing teak or Tectonagandis plantation at the Perum Perhutani. So he is graduate from the Gajah Mada University and got a master's degree at the Northern Arizona University. So it's time to yours give a presentation. Mr. Natalis, you have 20 minutes to explain. So please give a big applause for Mr. Natalis.
Good afternoon, ladies and gentlemen. Yeah, thank you. My name is Natalas Anis Harjanto, or you can just call me Anis, A-N-I-S. So it's simple and easy to remember. I'm the Operation Director of Perum Perhutani, state-owned forestry company in Indonesia as a Director Operation. And I'm responsibility start from seedling, planting, protection forest, and also harvesting. That's my job. In this time, I would like to talk about the next slide. Seven items. The first that I would like to talk is about Perhutani Group at glance. In this term or in this aspect, I would like to talk about what is Perum Perhutani Group. And the second, I would like to talk about organization or structure Perum Perhutani. And also, I would like to focus in Perhutani Plantation. And next, about teak plantation through the years. And the 5, thinning of shoot cutting Perhutani teak plus. And also kopis system or opslah kultur in teak plantation. And the last one is digitalization in forest management and marketing. That's the outline that I would like to talk. The first, next slide. This is the area of Perum Perhutani. You can see there is 5 main island: Sumatra, Kalimantan, this is Sulawesi, Java, and Irian. So actually Perum Perhutani has only in Java, here, only in a small not small island, but one of five main island in Indonesia. This one. This is Perum Perhutani. And Perum Perhutani, the area of Perum Perhutani is 2.4 million hectares. And what is the main portfolio of Perum Perhutani? Perum Perhutani focus in log, in wood, and second, we also have an industry. We also have ecotourism, and also we have a pine resin and kayu wood oil. Also, we have others like a coffee and honey. So we have a 6 main portfolio in Perum Perhutani. Next, this is the organization structure of Perum Perhutani. We have a board of commissioners and also board of director. So we have 6 board of commissioner and also 6 board of director. One of board of director is me here in director of operation. Next, this is Perhutani area in Java that I mentioned before. And in Perum Perhutani, we plant many of trees. We plant teak plantation here, and we plant also pine. We also plant mahogany and also plant agatis and others. But basically, teaks is almost dominant in Perum Perhutani. It's almost or more than 50%. We plant teak. So if you see here, the red one, the red one is teak plantation. Here is teak plantation. The red one. And how about the blue one? The blue is pine. We have many here, but basically the dominant plantation is teak. Next slide. So let's talk about teak in Perum Perhutani, in my company. So basically, before 1980, we plant teak with local seed. No treatment at all. We have seed and then we plant before 1980. But in 1996, we try to increase not only seed, but we try how to plant seed in treatment. So we collect the good trees in one area and then we take the seed. But we choose the best trees. And then right after that, we have shoot cutting. So this is a vegetative scheme to improve the quality of seed. So we have about 452 889 hectares teak plantation, but consists of local seed conventional teak, seed production area, clonal seed orchard, and also shoot cutting. And we try to take the growth performance from the conventional teak is very low performance. Volumes in 5 years is only is only 28.7, and in years 20 years old, this is 110.9. And how about the seed that we already treat? This is increased, but the best is in shoot cutting. In shoot cutting, in 5 years old, we have 5.1 and 2 meter cubic per hectare, and 10 years old, we have 199.76 meter cubic. So it's clear that shoot cutting is the best here. And this is the difference between seed from the clonal seed and seed from the superior clones from shoot cutting. This is the difference. So we planted in 2011, and then we cut in 2021. I mean the diameter, we measure the diameter 15 centimeter and the height is 12 meter. And how about the best one? We measure the diameter 20.8 centimeter and the height is 20 meter. So the shoot cutting is better than the seed production area. This is in the same area. And I think tomorrow or maybe on Wednesday, ladies and gentlemen will come to this place to take a look what is the difference between seed from the clonal seed, from shoot cutting, and also from from the difference from shoot cutting and the clonal seed orchard. And also how about the quality of the wood? This is mentioned that actually teak, conventional teak, will cut in 60 years. But Perum Perhutani want to decrease the years, so we can cut in 25 years in order to increase the revenue. So we have we have no take a long time to harvest, but 25 years we already harvest. But the problem is the quality. Why? Because the quality in 25 years, the wood is softer than we compare if 60. So this is the problem. But University of Gajah Mada helped me to how to create this problem into the opportunity. So the main problem is, or the main purpose is how we can cut 25 years, but the quality is good. That's the purpose. Okay, next. This is the treatment that Perum Perhutani done. By doing thinning, soft thinning, this is soft thinning, and below is a hard thinning. So in order to maintain the quality of teak, we do thinning. And this is the thinning that Perum Perhutani done, but very soft thinning. But this is, we try also another pattern with the hard thinning. And this is the result. Yeah. If, or the more harder we do thinning, the more we get. This one. So basically, thinning purpose to increase the volume of trees, the wood trees. Next. This is also the treatment that we already done about opslah culture or copy system. Teak has ability in sprouting. So that's why we do also make regeneration or rehabilitation, not by seed, but we copies. We cut the trees and then we'll sprout right after this. So we plan in 2004, and then in 10 years, 2021, 10 years old, the average diameter is 18 centimeter and the height is 18 meter in high. Yeah. This is the comparison between thinning and copies and not copies. I mean, this is also, this is the difference is the age. This is without thinning, copy system, but this is thinning, copy system in here. So the difference, we can see the difference here. And then the next, digitalization in forest management and marketing. This is the last slide. Actually, Perum Perhutani in managing the forest, we use digitalization. So reforestation in 1 year, we plant 10 to 20,000 hectare per years, and we use also drone to monitor the reforestation, and also production 500 meter cubic logs per years, and we do marketing with the application. The name is tokoperhutani.com, and also we manage the local people in managing the forest. In Indonesia, the number of population is the main problem. maybe in developed country, we can say, don't touch the forest. But not in Indonesia. You cannot say, don't touch the forest. If you say, don't touch the forest will not sustain. So that's why we have to involve local people in managing the forest. That's why Perum Perhutani make application with this one, application, which is an application. We have farmer, we have bank for supporting the money, and then also we have like, what do you call, people who give teats to the farmer. So that's why put in one application. In one application, you can dialogue. So if farmer want to say or want to increase the quality of agroforestry, they just say in application, say that how to make my corn, for example, a high production. So we have again a socio-forest, the application. That's, I think, for from me, from Perum Perhutani, that's I hope can increase the knowledge, our knowledge. So if you have any question, maybe you can ask later. Thank you very much.
Thank you very much, Mr. Natalis Anis, for the explanation about the ticks in scale, the large scale in the Perhutani area. So, move to the next session. I will to open the Q&A time session. Maybe in the first, I will give a three participants to ask to our speakers. Please raise your hand and state your name. Okay. Please the microphone to Sumura Sensei.
Thank you very much for the very interesting talk. So, in my talk, my name is Monsoon from Japan. In my talk, I'm very interested in about how to
Thank you very much. Okay. Mr. Simon, you can answer the question first.
Thank you very much, Professor Tani, for your question related to the wood quality. So this is my another topics. I may share you with the result with our data we have. So in the Luang Prabang point, the result indicate that in terms of the wood qualities, the ticks where the plus with indicate the glow have a good glow performance in the bottom of valley or in the lower slope. So, but in case of wood properties, particularly is the basic density and color is the high quality is the middle slope position because of the moisture content. Particularly is the wood colors is lower of the valley, bottom of valley is the color is the light yellows, but in the middle of slope is the golden yellow or brown yellow. But in case of the market related to the price, but it's a minor difference between the price because of the right now is the color is the they can make with this. If you would like to more brown or more golden, we can use the appropriate color from the synthesis colors. Yeah. So that means that in case of the basic density, in the upper slope where the thick glow is slowly, it requires hard than the side that the tree is grow faster. Yeah. Thank you. Yeah.
Okay, thank you. Next, the answering from the Mr. Natalis Anis about how to improve the quality of the wood in the future.
Thank you. Yeah, actually, we need. Perumbu Tani is not scientist, yeah. It's not scientist. We are doing in operation, so that's why Perumbu Tani asked to University of Gadjah Mada. We have 2.4 hectare, 2.4 million hectares area. So I think this is the good place for university to study how to improve the quality. Yeah. I think the best thing here is how to shorter the years. From example, takes usually in age 60 we cut the trees, but Perumbu Tani asked to University of Gadjah Mada, please tell me how to get quick revenue, 25 years, but with the good quality of woods. And universities say that we have to make a technology which is with the softwood, because only 25 years, so it's not enough, it's not adequate, it's not tough, it's not strength, the wood. That's why there is a technology like how to dry the wood, and then make some experiment how to improve the quality of wood. Yeah. Basically, we do drying. And also, seed is also important. The quality of seed. So that's why Perum Perhutani use the best one that we call shoot cutting. Means that we hope that the tree's mother is the same with the, what do you call, with the children, yeah, with the children, the same quality. So we use good quality seed by taking the same type, the same characteristic with the mother. That's what Perum Perhutani do for increasing the wood quality. I hope this has helped you.
Thank you. Thank you very much. Maybe next question for other participants, please. Okay. Miss Mirza.
Okay, thank you for the opportunity. First, my name is Mirza, and I'm currently a student in Faculty of Forestry, Gadjah Mada University. So both of the speakers here, I would like to say thank you for the explanation, and all are very insightful. And maybe these questions will be given to the Mr. Natalas. Yeah. Before you have mentioned about Perhutani effort in improving teak quality, you have mentioned before that, and also Perhutani have done successfully in decreasing the age of teak for cutting. And this day, maybe what will Perhutani do for the next few years? Maybe is there any new plans regarding the research about wood quality of teak? And also, is there any opportunity to collaborate with other institutions such as Gadjah Mada University maybe? Thank you for it.
Thank you. Mr. Natas will answer the question.
Yeah, it's almost similar. Yeah, the question with gentleman from Japan. No? Yeah? Oh, Tansa. Okay. Yeah. Basically, we follow the market. We follow the market. Market sometimes need the softwood, and the price is not expensive. So that's why we also try to sell the wood or the trees to the industrial that make a new model. For example, we join with IKEA. Yeah, we are trying to business with IKEA, because IKEA no need strong or strong wood. They need a soft wood, and also make a variant model. The important thing is the model change. So basically, Perum Perhutani, in order to going concern, to going concern the company, we try to sell what is the need of market. And in order also to get the more revenue, we are trying to do other business also with a company that have responsibility to pay the tax of what do you call the emitter, like mining. So we join with Pertamina in order to like net off. Pertamina is emitter and Perum Perhutani or my company, vice versa. This is the strategy that Perum Perhutani want to get more revenue, because I don't know, maybe sometime government have a regulation that we cannot cut the forest anymore. We cannot cut the trees anymore. And I think this is for me, I think this is possible. So that's why we also try to make collaboration with the mining, with like a Pertamina or like Adaro, something like that, in order that we are trying to decrease the harvesting, the cut trees, and then try to make trees not cutting, but we have revenue from what do you call, like forest, other land use, carbon trade. That's that Perum Perhutani try to do that. So cut the trees also we do, and also try how to not cut the trees. We maintain the trees, but get money from carbon trade. That's all? Okay, thank you.
Thank you very much for the answer the question. So maybe the last question to the participants. Any question? No? Okay. Okay, I think there's no question for the participant, but I have one question to Ms. Dr. Simon. I think it's very interesting research, but how to make sure that effect of the characteristic the woods is affected by the environmental, not only from the genetic or interaction between genetic and environmental. Could you explain about that? Thank you.
Thank you for your questions. Related to the genetic at first, right? And also the elemental and environmental factor, how to measure, right? So in our study, we focus on topographics. We use the normal equipments like GPS or like sloping guardians, measurer, yeah. And for the like color, right? The second point that you mentioned, I forgot. I forgot. So sorry, it's the second point.
My question is how to make sure your parameter is affected only by the environmental, not from the genetic or interaction between genetics and environmental.
Sorry. Okay. In case of genetics, we Actually, it's in the Luang Prabang, during the 1990s, the local government they has the strong support to the farmer to grow the ticks, but the genetics origin for that's the provide for the farmer is not the over control. Yeah, that's something that that's why the our study not is exclude for this the factor. Yeah. Thank you.
Okay, thank you. The question to answer of the question. I think we are in the last session. So before we close, I will brief some resume for our presenter. Mr. Simon talked about how to the result of the Simon research is suggest that the teak planted at the lower slope has faster growth rate and that there is interaction with the general converse slope. And from the Mr. Natalis, we learn how to management in the scale, the large scale of teak, especially in Indonesia. So thank you very much from the all participants and all the very interesting discussion and also very insightful presentation for all presenter in the session, 3 presenter before and also 2 presenter now. So please give a big applause for our speakers. Thank you very much.
Thank you very much to all of the experts, and we would like to say thank you to the moderator, Dr. Nesti Pratiwi Romadini Eshut.
And please, for the speaker, please remain on the stage because the organizing committee would like to present token of appreciation to the speaker, and we honorably invite Professor Nauki Tani from JIRCAS to present the token of appreciation to the speaker.
Again, we re-invite the moderator, Dr. Nesti Pratiwi, to take the photograph. And please remain on the stage. We re-invite again the all participants to to have the group photosession in front the stage. Please, the all participants. We will have the group photosession in the ending of this session for day 1. Dr. Savitri, Prof. Sri Rahayu can join with us to have a photo session. Please, all the participants can join us in front the stage, please. 1, 2, 3. Jogja cheese. Okay. Oh, there are so many camera. Thank you very much for all the participants. Now we have come to the end, the International Teak Seminar 2023 for day 1. Thank you for all of you who have participated with enthusiasm for the beginning to the end of Teak International Seminar. And please give applause for all of us. Thank you.
Ladies and gentlemen, before you leave this hall, we cordially invite all participants to enjoy dinner at 6 p.m. on Balai Timoho Restaurant. We will start from the hotel lobby at 5:30 p.m.
Thank you for your attention. Good afternoon, and I have one pantun for us. Ikan hiu makan sawo.
Cakep.
See you tomorrow. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.